is one of them. And in production and general engineering department, we have got 27 sectional committees dealing with various kinds of subjects, right from the basic engineering, drawings, fasteners, machine tools, hand tools, and bearings is one of the sectional committees, one of the areas where we are working. So under the guidance of Dr. Manish Roy, under his chairmanship, PGD 13, that is Bearing Sectional Committee, is functioning, and in his guidance we have formulated 87 standards till date. Out of 87 standards we have formulated 60 standards are adoption of ISO IC standards, and 27 are our own indigenous standards. So as I have told you earlier, BIS provides a platform for all the stakeholders to come together, discuss the things and formulate the national standards. We follow the principles of good standardization practices given by WTO. These are openness, transparency, effectiveness and relevance, coherence, and development dimensions. So whatever drafts we formulate, our committee formulates, that is open to the general public for its comment, and anybody can comment on any standard, any draft, and those comments are discussed threadbare in the sectional committee meetings, and decisions are taken accordingly. So no comment whichever is given by anybody is just set aside. It is thoroughly discussed in the committees. So we have got a very transparent, very open system. So that's why our standards stand a very good reputation in international area also. As far as the bearings are concerned, we all know that bearings are a very critical component of any equipment. Without bearings, we cannot imagine any equipment to function properly. Not only they reduce the friction, they provide support to the load, they transmit power, they maintain alignment and ensure efficient operation of any equipment. And it will be relevant to mention here is that the bearing industry itself, it's of the size of around $40 to $50 billion throughout the world, and it has got a significant contribution in the CAGR. So because without bearing we cannot imagine any machine to function. Bearings have a very important role for any equipment or any machine to function. Now we have got standards on plain and rolling bearings, but nowadays new technology is also coming up in standardization in the bearings. For that standardization will be needed in future. Some of them are integrated bearings, for me particularly while I was interacting with automotive sector, they were talking about integrated bearings. So these bearings are also coming up, or for that standards will be needed in future. Apart from that, application specific bearings for agricultural machinery, weaving looms and textile industry, turbochargers, etc. They are also in the pipeline, they are in the making. So these also will be requiring standardization for any kind of certification to happen. Standards are needed, and standardization will be done through this committee only. So we have to work on that. Nowadays, I was discussing with Madam of Tata Motors that we are using the simulation software to match bearing design with actual operating conditions without undertaking expensive and time consuming field or laboratory testing. So this is one of the area where simulation is very useful as far as the design of the bearings is concerned. In addition to this, we are also doing bearing condition monitoring to check before a catastrophic failure happens in the equipment. So this is also a new technology which is being used in the bearing manufacturing and its operations. Nowadays, many bearing manufacturers in the world, they are working towards sensorized smart bearings, which will communicate their operating conditions continuously with internally powered sensors and data acquisition electronics. So that is one thing on which currently we don't have any standard. We'll have to think about that in those terms so that the smart bearings can also be standardized in future. New materials have also been introduced which have extended the life of bearings under severe operating conditions and have boosted the performance and improvement efficiency. Even in conditions where no lubrication will work effectively, this is achieved through some of the innovative materials, specific heat treatment and specific geometry of the bearings. Improvements have also been made in the surface texturing and wear resistant coatings. For example, tungsten carbide coated balls are both wear and corrosion resistant, which are suitable for high stress, high impact, low lubrication and high temperature conditions. Now, the challenges which bearing industry will face in future is that meeting the requirements of low emission, improved safety norms, lighter products and lower friction and noise, improved reliability and expectations, and low carbon footprints and sustainability requirements as given by the SDGs of United Nations. Now, our role as a standardization body begins that the standards which have been formulated, they should be updated in line with the technological advancement made in the bearing industry. So with this, I think a day is not far off when we shall have not only a machine readable standard, but also machine interpretable standard, which will interact with the machines to communicate what all modifications are required in various machine elements. So with the introduction of AI and all, this is going to happen sooner or later, but this will happen, I'm sure about this. And for the manufacturing of a particular machine element, the manufacturing machine itself will provide the real-time data for the dimensions and other requirements, along with other statistical parameters such as range, mean, median, mode, standard deviation, mean deviation, etc. Compare them with the specified values given in the standard and accept or reject them and suggest further improvements in the standards if required. So all these things, the machine itself will tell you how to do, what to do, and where the changes are required in the standards. All these things are coming up, I think, in the ISO level. They have started writing the standards in such a fashion that the machine will interpret it, what all the requirements are there, and machine itself will give feedback as to what improvements can be done in the standards. So these are all futuristic things which we have to do it, and the sooner we do, the better it will be for our industry and our country. So we have got various slogans given, like Atmanirbhar Bharat, Make in India and all. But one slogan, I think, which has not been given by any quarter is that standardize in India. So once we start standardizing in India, we will be investing in R&D, we will be starting doing innovations, will create designs, will standardize the things, and we'll also be able to internationally standardize the things. So we'll be pioneers in the field. We have to, if we want to become the world leader in bearing technology, we have to think in those terms where our standard becomes the first in the world. So if we have a vision of becoming world class, we have to think in terms of standardization also. Standardization becomes a very important thing, very important aspect. So all those countries which are in the higher level of evolution of technological advancements, they are also higher in standardizing the things. So we also, as a technical fraternity, we also have to think in those terms so that we start standardizing in India. And I am very sure that with the help of all the eminent members, all the learned partners which we have, the day is not far off when we'll be having a leadership in the international arena also. So with this, I welcome you all once again in this seminar on bearing technology and standardization. And I hope the presentations given in the technical session as well as in the inaugural session will be very useful for all of us, and it will just guide us towards a future standardization. So thank you so much for joining. I wish you all the best. Jai Hind.
Thank you very much, sir, for welcoming our guests and setting the stage for the next session. So this is time for the keynote address, and our keynote speaker, Dr. Manish Roy, is the chairman of Bearings Sectional Committee, PGD 13. Dr. Manish Roy graduated from IIT Kharagpur in 1985 in metallurgical engineering. After a short stay with the integrated steel plant as junior manager and his post-graduation, he joined DMRL in 1989 as scientist. His area of research interests are materials and surface engineering for tribological application and nanotribology of self-lubricating films. He is particularly interested in various interactions between oxidation and tribology and also between corrosion and tribology. Dr. Roy's contribution to scientific community extends beyond the boundaries of his laboratory. He has visited University of Strathclyde under bilateral exchange program of India National Science Academy and Royal Society London in 2001. He visited Vienna University of Technology as Lise Meitner International Fellow of Austrian Science Fund. He has also visited Austrian Center of Competence for Tribology as Marie Curie Fellow of European Commission in 2007. Dr. Roy's dedication to sharing knowledge is evident through his extensive publication record. He has authored approximately 100 papers in various esteemed national and international journals. Notably, he has edited a book titled Surface Engineering for Enhanced Performance Against Wear, and he is currently working on second book, Thermal Sprayed Coatings and their Tribological Performances. So he is in the editorial board of International Journal of Refractory Metal and Hard Materials, recent patent in Mechanical Engineering, International Journal of Manufacturing Materials and Mechanical Engineering, and International Journal of Surface Engineering and Interdisciplinary Material Sciences. Dr. Roy has organized several international symposiums in India and abroad. Dr. Roy was convener of the first and second international conference on tribocorrosion held in India and Austria respectively. Ladies and gentlemen, let us welcome Dr. Manish Roy to the stage with a round of applause. We eagerly await your address, sir. Yes, sir.
So, very good morning to everybody. Please note and understand that I am not a speaker. So, on behalf of BIS in particular and also on behalf of Tata Motors, I would like to welcome you all for this special seminar, which is exclusively on future direction of standardizations of bearings. I would like to profusely thank Tata Motors for giving us this opportunity to organize this seminar. And this seminar is essentially intended to formulate few more committees under our Bearing Sectional Committee, few more subcommittees. Today's primary title, as mentioned previously, is on magnetic bearings. Frankly speaking, although I am chairing this Bearing Sectional Committee, never ever in my lifetime I have worked in magnetic bearings. But fortunately for us, we have several experts of international standards working with us, with our group, for this particular committee and for standardizations of this bearing. As mentioned previously by my previous speakers, that there are a lot of smart interactive bearings and a lot of innovations, both in terms of materials as well as other interdisciplinary sciences. Many more inventions are coming, and hence it demands that we are going to integrate many more experts from different areas and expand our committee to make this more effective and more productive. Today we have a series of exciting speakers, and I think we are running a little bit short behind the schedule. So it is best that we start our seminar as early as possible. I request everybody to actively participate, and we should spend extensive time on interactions after each speech. So I would rather request speakers to limit to that scheduled time and give more time for the interactions. So we have our first speakers. Oh, Acha, I think there is one more inaugural address for this. Then, following which we'll start for our thing. And Professor Rajiv Tiwari from Mechanical Engineering Department in IIT Delhi will be addressing at the first talk. But there is another inaugural talk just after my talk. Thank you very much. Thank you everybody for actively participating for this sectional committee as well as our seminars.
Thank you, sir, for welcoming the gathering in the seminar. And ladies and gentlemen, it is now time for the inaugural address, and we are honored to have with us Madam Asmita Ghate, GM Quality Analytics, Engineering Quality, Tata Motors, Pune. Madam has over 2 decades of experience in automotive domain. Her area of expertise include engineering quality, standardization, data analytics, system automation, and manufacturing IT systems. Currently, she is heading Quality Analytics Department of Engineering Research Center at Tata Motors. She is a Fulbright scholar from Tepper Business School, Carnegie Mellon University, and a member of Bureau of Indian Standards Statistical Methods for Quality, Data Analytics and Reliability Sectional Committee. She is also a member of ISO Committee TC 69 SC8 on application of statistical and related methods to new technology and product development process. She is also Tata Business Excellence Model Assessor and Practitioner. So it is our privilege to have her with us today, and we request Asmita ma'am to kindly give the inaugural address for the seminar. Ma'am, please.
So very good morning, and first of all welcome you all. I'll not be taking much time. My role here is to represent Mr. Preetham Merchant. Preetham is engineering quality head, and he was supposed to be here with all of you today, but he had to travel to Bombay House for one urgent meeting. So I stand here to represent Preetham, and I'll just be welcoming you in a little formal way. So first of all, on behalf of Tata Motors, I would like to welcome Shri Rajiv Ranjan Singh, Head Production and General Engineering Department of BIS, Dr. Manish Roy, Chairman of Bearings Sectional Committee, Brigadier Dhankar, we are privileged to have you here, sir. Kundan Giri, Member Secretary PGD 13. I would like to also welcome all the distinguished speakers. It is privileged that Tata Motors is hosting this gathering, and Tata Motors association with BIS goes like 5 decades. Many of our experts, apart from working in the automotive day-to-day deliverables and really hooked on to the timeline, it's our privilege to participate in the Bureau of Indian Standard Committees, work on learning on the various expertise which are given by the members, and also share some of the knowledge which we have. We have our own standardization team, and Ramesh Kulkarni, who is sitting here, who leads that in Tata Motors. Various standards are incorporated onto our drawings, and our journey towards customer delight goes only through standardization. So no matter we might be really working on AI, ML, new technology, automotive industry is really shifting the gears, and automotive is nothing but the smart device on the wheels. But this is not possible unless and until we have a very solid foundation layer, and which is based on standards only. So we are very, very happy that this session, and specifically on bearing, is organized, and Tata Motors is happy to host this event. Thank you for all of you joining here, and wish you a very good and fruitful day ahead. Thank you.
Okay, thank you, ma'am. And Before we move on to the technical session, we would like to have a tea break at this point of time. And it is 11:10 and we will be reassembling at 11:30, 20 minutes break. So let's break for tea and then come again. Okay. Welcome back, ladies and gentlemen. And now we will start the first technical session, that is on magnetic bearings. Our technical session will feature some of the best minds in the academia who will share their knowledge and insight on various aspects of magnetic bearings. And each presentation will be around 30 minutes long. And the chairman for this session will be Dr. Manish Roy. He will be reminding the speakers about when the time is going to get up, almost up. And during the presentation, some people are viewing this presentation YouTube live. So if there are any questions in the YouTube chat box, that will also be asked during the question answer session. And we will take some few questions at the end of each session, and we will have a detailed discussion at the end of the complete technical session, that is on the magnetic bearings. So our first speaker for this session is Professor Rajiv Tiwari. So Professor Rajiv Tiwari is from the Department of Mechanical Engineering, Indian Institute of Technology, Guwahati. He has more than 35 years of teaching experience. His research interest lies in the areas of vibrations and rotor dynamics, with expertise in the domain of experimental estimation of rotor bearing parameters, rolling element bearings design and analysis, active magnetic bearings. He has published more than 100 research papers in national and international journals. He is associate editor to the Journal of Vibration and Control Springer, associate editor to Journal of Vibration Engineering and Technology, Sage Publishing, and technical committee chair to the proceedings of the International Conference on Vibration Engineering and Technology of Machinery. So I request Rajiv Tiwari sir to kindly start his lecture, and I will request Kulkarni sir to welcome Tiwari sir with a bouquet and a gift from us. Yes.
Yeah, so good morning to all of you, and I think I'll be talking on magnetic bearing. Very introductory lecture is there on this. I'll try to cover basics so that people can follow this particular topic, and because my two fellow speakers are there, will be I think talking about more on the application part and or how this can be used for the industries. So this is the outline of my presentation, in which I'll just introduce the levitation, and then about the magnetic bearing. Different classifications of the bearings are available, and then on very basics of the active magnetic bearing. Especially when we are talking about active magnetic bearing, that means the property of the bearing can be changed during the operation, so actively, depending upon the requirement. And then advantage of the magnetic bearing as compared to the other kind of bearings which we have. A few industrial applications, especially the research wise, what people are doing it, I will give just glimpse of that. Also I will give few slides on the what are the things we are doing at IIT Guwahati at research level on the magnetic bearing. So this levitation is that long back people dream to levitate any object on the air, and in I think 1842 Earnshaw he proved that a body cannot be levitated by a magnetic field if a body is in stationary condition, or the whatever the magnets are in the stationary conditions. So that 6 degrees of freedom, as we know, of any particular body, so that cannot be controlled by this permanent magnets. But there are some exceptions to that. if we have some kind of active control of the magnetic field, then we can able to levitate the system. And there are some other exceptions are there. If we can have some constraint in the body, if we can restrict some degree of freedom of the body, then also with permanent magnet or combination of this active control, we can able to levitate. So I'll just brief how this particular magnetic bearing works. Lighter is there. Achha, okay. So this is a rotor, as we know, which is generally conventionally supported by rolling element bearing or the fluid film bearing. So here instead of that, we have electromagnet. This electromagnet is providing. So this is providing some kind of magnetic field. So because this rotor is having weight, so this magnetic pull should counter that particular weight, so that this remains in this particular operating position. If any disturbance in this rotor is taking place because of whatever reason, this particular sensor, which is maintaining the gap between the rotor and the sensor, that senses there is some disturbance, and then it gives signal to the controller. Controller, based on the control law, it gives some signal to the amplifier what current in the electromagnet we should change to counter this particular disturbance by changing the magnetic pull or push pull of this. So generally this is a very simplified version of this. This kind of electromagnet can be there at the bottom also and in the left and right side also. So 4 direction forces are pulling this particular rotor, and because of that, that is in the equilibrium position. So any disturbance in that will be controlled by the change in the electromagnet. I will just give a small video regarding the levitation. So this is a levitation by the permanent magnet of a spinning top. So now you can see that this particular rotating top is levitating on air, and this is due to the 2 magnets, one at the bottom which is ring type, another is there on the spinning top, that is also a ring type magnet, and you can see the magnetic field here. The this particular top will be in equilibrium where the magnetic field is getting changed direction. So this is one of the example how the levitation can help in the, but here once the stop rotating, it will drop. So the condition should be that it should keep rotating, then only we can able to levitate this. Sorry. So coming to the classification of bearing, based on various types it can be classified. One of them is the how the magnetic field is flowing through the shaft. So in this particular thing, this is the shaft. So these magnetic bearings are basically, you can see the field is in the parallel to the shaft's axis. And if you see the other view of the same magnetic bearing, in this particular case you can see the pole, north pole. So all are the north pole in this side of the magnetic bearing. This side is south pole, that is back of this. So because all poles are same, so that's why it is called homopolar. And this particular, as I mentioned earlier, to make the flow of the magnetic field closed, we need to have north and south pole. Okay, so here this is, we can able to count. Okay, this is 1, 2, 3. Similarly, if you count like this, there will be 8 such poles which is balancing the rotor. So that's why it is called 8-pair pole magnetic bearing. This is one of the classification in which the magnetic flow is in the axial direction of the bearing. Another is this one, in which you can see now this is a magnetic actuator, this is the shaft. So this is one of the electromagnet. In this north to south the magnetic field is flowing, but now you can see the flow of the field is in the circumferential direction, not in the axial direction. And in this case also the magnetic force will pull in 3 directions to balance this particular rotor. So this is called 3-pair pole, and now you can see the in the axial direction as compared to the previous case. Now here north south, that kind of hetero, that's why it is called heteropolar bearings. This is another kind of classification based on the magnetic flow. This is also heteropolar, but now you can see there are 8 pair of poles. So this is 1, 2, 3, 4. So as compared to the previous in this particular case we need more complex control action. Here the control action, even number of poles are increased, we can have some kind of differential control action. So if we are increasing the force there, we can decrease the size by the same amount. Similarly other 2 pair. So this is, you can see there are 4 pair poles of the magnetic bearing. This is also hetero because you can see there is north south poles are there in this. So this is one of the actuator which we have in our lab. So this is the same 8-pole heteropolar magnetic actuator. So this is the same actuator. You can see there are 8 poles, pair poles in this. So this is a magnetic actuator. This is the shaft will carry this particular core, so that the magnetic losses are less, because the steel losses will be more. So these are silicon steel. So in this particular case we need to provide core onto the shaft on the journal, so that the magnetic field will flow through this and the losses will be less as compared to the steel, pure steel. This is another type of bearing in which this is a thrust bearing. So this is also from our lab. So this is you can see that there are 4 pair of actuators are there. Top of this there will be a thrust disc, and above the disc there will be similar actuator will be there. And I think I'll just show this one. So you can see this is one of the pole I have shown in the previous slide. This is the disc, and at the bottom also there is a actuator. So magnetic field is flowing through this and like this. So both the actuators are pulling toward each other, and to counter the weight of this, obviously the upper actuator will be pulling more as compared to the lower one. And so this is the disc, and we should have this kind of actuator at the bottom and the top of the disc, which will be giving a thrust force to that. So you can see this is a vertical shaft, and the disc will have one at the bottom and at the top, and by that way it can be actuated in the vertical direction. So this is also from our lab, this particular rig which we are developing. Okay, and this is the magnetic field calculations we have done, in which you can see there are 2 poles and 2 this side. So there are 4 at the top and 4 at the bottom, and the magnetic pull we can able to calculate using this kind of softwares. Okay, so again classification, still I am continuing with that. So we can have either the passive magnetic bearing or the active magnetic bearing. So passive, as we already seen, the pure levitation. So in this we need to have some constraints, then only we can able to levitate the bearing, or otherwise it is unstable. But active magnetic bearing, we can able to control the things, but we require controller and the amplifier to do that. So this is another kind of classification we can able to do for the magnetic bearing. Sometimes we use combination of the electromagnet and the permanent magnets. So with that we can have the either repulsive or attractive type of force to the shaft from the bearing. So based on the placement of the north and south pole, we can able to provide either repulsive force onto the shaft or the attractive force onto the shaft. So this is another kind of classification. Sometimes, as I mentioned in the introductory slide, that we require displacement sensor to find out the operating position of the bearing, and if so, that is another kind of classification in which we use sensors, and sometimes we don't use sensors and displacement sensor, but Hall sensors based on the magnetic field. We can able to obtain the magnetic field intensity, and we can able to we can have the controlling action with that. Yeah. So as for the other kind of bearing, here also we can have axial or thrust magnetic bearing, radial or journal magnetic bearing. Even people have tried out the conical magnetic bearing, in which both combination of the radial and the axial thrust can be given, just like taper roller bearing. Similarly, here also people have tried conical magnetic bearing. There are several type of classification which we can able to do based on various criteria. These are some of the criteria. I will not go into much detail on this. So like according to the magnetic effect, electromagnetic bearing, and then there so many other classifications are there, like ferromagnetic effect, diametric effect, or superconducting material. This is one of them. Then according to the magnetic effect, the continuation of that, electrodynamic bearing, in which permanent field or the AC current, induced current, controlled current with the permanent magnet combination. So many criteria are there in which people have tried the classification of this. So I think here we have lot of potential, especially because we are talking about standardization of the bearing. So classification could be one. I think standardization we should focus on this. Coming to the application, gradually you will find that especially where the speed is the main criteria. If very high speed is there, when we are talking about 1 lakh RPM or more than that, then this magnetic bearing is having definitely advantage, and some of the applications I will be describing in the next slide. So this is one of the application in which you can see this is a shaft. There are 4 bearings, all are active magnetic bearing. The last one on this end, drive end, these are the bearing which is supporting the shaft on air with the magnetic actuation. In between there are 2 more magnetic bearing. They are providing some kind of aerodynamic instability or aerodynamic load which is actually there in the turbines. So yes, in this particular case people are simulating aerodynamic effect through this magnetic bearing. So not only we can able to use the magnetic bearing for supporting, but any kind of excitation if you want to simulate, that also we can able to simulate using intermediate ones, and then we can able to check whether the supporting bearings can able to suppress that particular instability or not. So this is one of the application, and this is the test trick for that from some other author. So these 2 are the supporting bearing. These are the disturbance bearing which are simulating aerodynamic instability into the rotor, and they are controlling that particular instability. Another application, if there is some kind of rub between the rotor and stator, so this active magnetic bearing can help in that. We can have some operating position of the shaft, and if it is going beyond that, so this particular disc will touch stator. If this magnetic bearing is not there, this gap will close, and there will be rotor and stator interaction will take place. But if magnetic bearing is there, we can able to have operating position of that, and as soon as this particular disc is going close to the stator, this will actuate and that will suppress that particular disturbance. So this is another application of the magnetic bearing. So this is, here you can see, it is not supporting it, the shaft, but it is acting as a controller to suppress the vibration. This is the rig, I think the design in which this is the magnetic bearing. Yeah, this is a magnetic bearing, and here that particular stator rotor interaction was taking place, so they could able to suppress that. Another application is the oil valve which take place in hydrodynamic bearing. So these are the hydrodynamic bearing, the shaft is mounted on that, but this magnetic bearing is suppressing that particular phenomena if it is occurring based on if there is a large oscillations of the rotor, this magnetic actuator will act and that will suppress that particular disturbance. So this is another application of the magnetic bearing. This is the test rig the authors have designed. So you can see the rig, and this is the hydrodynamic bearing, and this is the magnetic bearing which is suppressing the oil valve phenomena. Another example is the compressors, the surge phenomena in which there is an instability condition of the pump. So that also, so here, so this is a compressor, you can see the blades of this, and this yellow, two yellow are the radial magnetic bearing. In between there is a thrust bearing. So here the impeller axial clearance was controlled by the thrust bearing, so that this compressor works in the optimal working condition or optimal efficiency conditions. So the axial thrust was controlled by this particular thrust bearing, and so to maintain the pump always in the best efficiency point. So that is not only the axial control, so radial control, but axial control also can help in increasing the performance of the bearing. Yeah, so some of the advantages as compared to the conventional bearing now I will highlight. So now you can see that because there is no lubricant, so all the problems of the lubrication, wear, tear will be eliminated here, and especially when we are talking about some application where this lubricant may contaminate the other working fluid. So this magnetic bearing is having advantage, like vacuum techniques in which especially when we are talking about high speed, very high speed, here only friction is there between the air and the rotating rotor. So if we can provide the vacuum there, then that also those friction can also be eliminated in the bearing. So clean and sterile rooms like medicines and other applications, they have a lot of applications. Transport or aggressive or pure media, where we don't want any lubricant to get into the actual the whatever the fluid we are handling or the material we are handling. So this is a typical actuator and the core of the magnetic bearing. So this is one of the turbomolecular pump which is used for separating the I think especially in the separators they use this, in which especially the they are talking about the petroleum, if they want to separate various content of that, so they use this turbo molecular pump for that, and that operates at of the order of 1 lakh RPM or more than that. So for that, conventional bearings will give very high much heat. Then the application is there in the centrifuge, and even in the now people are using for the flywheel energy storage system. Not only this is being used for the power plant, because very large flywheel can be made, and that can be floated on the air with the magnetic bearing, and energy can be stored. And whenever there is a deficiency of the electricity, this energy again can be taken out from this. Even for the e-mobility, some kind of I think energy flywheel, they are using it in the automobile also. So I'll give some slides on that also, like this one. So already people are started developing.
Professor Paul,
Yes.
we have 5 more minutes.
Yes, please. So this is the some kind of battery, you can say, but this is not chemical battery. This is a flywheel is rotating inside and is levitated by magnetic bearing, and this is a mechanical energy storage, not the chemical one. So environment wise also is very good, and the life is also very high, of the order of 15 to 20 years life of this kind of storage system. So yeah, as I mentioned that the sealing and lubrication, those things will not be required then if we are using magnetic bearing. And this test rig was used for crack detection in the shaft. This is from our laboratory, and we developed some algorithm, and based on that we detect if there is a crack in the shaft. Based on the measurement of the whatever the actuation force we are giving to the shaft during the rotation of the cracked shaft. So in the conventional bearing, the capacity of the bearing is, the load carrying capacity is fixed, but here we can able to change. Not only that, we can able to change the stiffness and damping property of that also, depending upon the requirement online. Okay. So this I already explained, that the magnetic bearing is not only to support the load, but to control if there is any disturbance, it can able to control that particular disturbance of the rotor. Also we can able to give actuation force, like we have seen, we simulated the aerodynamic force, so that kind of force also we can able to simulate. So it acts as a bearing, actuator, and the some kind of exciter, we should say. Yeah, so I'll skip this part. I'll just go to the some case study which we are doing it. So this was I did in the Technical University of Darmstadt. So one test rig was there on the flexible, you can see very flexible shaft. So we did something on the dynamic balancing, flexible balancing of this rotor based on the magnetic bearing. So here you can see this aluminum frames are there, they are magnetic bearing, 2 magnetic bearing, and so we conducted some research to do the flexible rotor balancing of this. Then in here also in IIT Guwahati we developed rig in which we did the flexible rotor balancing for you can see there are 2 disc actuator here, this actuator is mounted there, this is the controller, and you can see that how much reduction in the vibration we could able to achieve after balancing. So this is a plot of that. This I already explained, the crack detection we did it with the magnetic bearing. So this is the overall circuit of the rig. This another rig we developed for the gear noise reduction and the finding the transmission error, how much quantifying the transmission error in the gear. So in this we used you can see there are 2 parallel shafts. This is the drive end and the gear is here, and 2 magnetic bearing we used to suppress the vibration, and we found that the noise was reduced, and also by the analytical approach, we calculated the transmission error in the gears. So I think, yeah, this is another view of the same setup. So here all other power supplier, amplifier, displacement sensors, amplifier, these are there. Yeah, with this I will conclude. So this is my book on rotor systems, if you want to refer. And I have some lectures on the rotor dynamics, mechanical vibration in NPTEL. Some of you may be viewing that. If not, then you can use that. So if you have any questions.
Thank you, Professor Tiwari, for such an elegant talk. Now we'll take only two questions, none from the academicians, one from the manufacturer and one from the users. So if there is any question. Oh, if there is no question, then I have a question. And that is, what is the potential of using this magnetic bearing at elevated temperature? Say elevated temperature, I mean something around 800 and above.
So obviously materials, materials. So only limitation is the material if that can handle. So, so if material can be developed, then I think this can be. But 800 at present, I have not seen the application for that. But obviously, material is the limitation for that. Yeah. Yeah.
Extreme pressure. So that any variation that is there, all the significant, we have a complex system. Can we make it simple by using some other means so that we can
People are using now the hybrid bearings, in which permanent magnet and the electromagnets, both they are using it, and sometimes even they are using foil bearing and magnetic bearing, permanent magnets. So combination of that will be, I think, advantages in that. Yeah, yeah, yeah. So, yeah, yeah.
Mr. Pankaj Kumar from CKSP Dev Road. Whether this bearing can be used in turbocharger side of the turbine side of the turbocharger, because in turbine side the temperature will go up to 700 or 800 degrees centigrade. So whether this bearing is suitable for that or not? Because if binding is there, where this binding can be resistant to that surrounding temperature. Surrounding temperature may go 700 or 800 degrees centigrade, sir.
Not aware of that.
Yes.
Elevated temperature, magnetic property loses. So NASA has demonstrated. NASA has demonstrated up to 560 degrees centigrade for turbo machinery application. With the one application paper, there is a maximum temperature so far. We have not seen.
So we will take rest of the questions at the end of the magnetic technical session. So we thank Professor Rajiv Tiwari for a beautiful lecture and addressing the questions of our audiences. Right. So just let me load the presentation of the next lecture and then I will invite the speaker. Right. So, our next speaker, Dr. Harish Hirani from the Department of Mechanical Engineering, Indian Institute of Technology, Delhi. Professor Hirani has made significant contribution as an administrator. He served as director of CSIR CMARI from March 16, 2016 to March 15, 2022. He held key positions in IIT such as Vice Chairman of JEE Advanced at IIT Delhi from 2014 to 2016 and President of CSIR Sports Promotion Board in 2021. Professor Hirani has received numerous awards and accolades. These include the Eminent Engineering Personality Award for IEI India in 2021, the Tech Samaritan Award for IEI Durgapur chapter in 2021 for his contributions in developing COVID-related technologies, and Outstanding Engineering Award from IEI Rajasthan State Center in 2021, among others. So he is a fellow of the Institute of Engineers and the American Society of Mechanical Engineers. As an esteemed educator, Professor Hirani has authored 2 single author books, one on fundamentals of engineering tribology with applications, and another on technological innovations for effective pandemic response. Dr. Hirani's contribution as a scientific leader are truly remarkable. He has developed and transferred 15 technologies to 55 MSMEs, generating a substantial licensing fee of around 305 lakhs. He has also made significant contribution to IPRs with several patents, design registrations and copyrights to his name. Professor Hirani's accomplishments have gained international recognition, including his prestigious Boyce Cast Fellowship at Massachusetts Institute of Technology and being featured among the world top 2% scientists in the ranking by Elsevier BV and Stanford University. So it is our privilege to have Dr. Hirani as a esteemed speaker in this event, and I will request Kulkarni sir to kindly welcome Dr. Hirani with a bouquet and a memento. Yeah. Thank you, sir. Now I will request Professor Harish Hirani to start his lecture.
Thank you, Kundan, for this opportunity, and morning inauguration time. Sri Singh has already paved the way that we really require some bearing technology which can speak its own, that I am at the fault, please change me. Or there should be a communication from bearing itself. That's what we are thinking about, smart bearings. And I believe that AMB is kind of smart bearing. Bearing can tell exactly what is the problem and how to correct also. That's a possibility. So this, my first slide shows the 2 books what Kundan has mentioned already. First book which I wrote in 2016, and an Indian edition also came in 2017. And second, because I have now more IPRs compared to my publication, so around 30 IPRs I have described in this book with a couple of real society purpose at why, and maybe we have developed a couple of technologies during COVID time. So today's topic what has been given to me is something like a magnetic bearing technology and application in industry, and thanks to Professor Tiwari, he has reduced my load by giving number of application in his slides. And as that Kundan has mentioned, my name, my designation, I don't have to repeat it. Now, when I wrote a book in 2016, there was something like tribology is going to play a major role in industry, and then what we realized something like we can save almost 5 trillion per year, and by implementing the real tribological the procedures, science and maintenance procedures, what I will mention. And then I realized at that time that many times books people are mentioning that Teflon or polymer coating or only the polymer is going to reduce the coefficient of friction and then maybe wear rate. We realize that's not correct. In some scenario it may be possible, but some other reasons we can even get a much lesser coefficient of friction. That's even a point not one also. Now we have achieved those things also in a laboratory using nanomaterials. So nanoscience and nanotechnology is very important to understand. And moreover, another thing is that we need to understand the physics on maybe say chemical structure the nano level. At nano level, everything looks totally different. What we find on macro level, and yesterday in the BIS standard also, I was requesting, can you change RA value to RMS value? Because RMS value is going to change a lot. RA value is not going to give that kind of reliable results. So can we do that kind of things? And in my view, if you spend even the 50% amount on this kind of equipment, whatever we are assuming, but returns will come within 3 years itself. The spending or expenditure on this kind of activities will give you the much better returns. Now coming to the sustainable, because society is looking for all sustainable solutions, whether we need to really reduce the friction or not friction, but we require sustainable solution. We require something like a product which is coming out is going to should survive for years and years and years, and there the tribology comes in a top, the materials of science comes in a top. Then we require a mechatronics, because active element what Professor Tiwari has mentioned, that without mechatronics we cannot do those kind of thing. And in my view personally, because as I spent 6 years at the CMRI, I found without manufacturing excellence, whatever we do, it will be zero. So without really going for the excellence in a manufacturing, you cannot achieve those results. So we require a kind of a combination of all. One discipline is not going to really help. That's why I felt that industry participation is very important. Whatever we have done as a IIT level, TRL 3 or TRL 4 is more than sufficient for us, because we get a publication, maybe TRL 6, 7 we get IPS, but finally the industry has to accept it. It should go to industry. That's why I felt that is important to understand what are the really senses and then how we connect it. These are all important to make a smart bearing, and AMB or magnetic bearing is smart bearing only. We are going to that side. And of course yesterday we had a lot of deliberation whether the magnetic bearing is a part of the plain bearing or not, and I'm trying to give how to go with the cost economics, how to make this bearing as a part of the plain bearing itself in this case. Now this is what I took a traditional from a book. That's what we have learned in engineering when we start how to select a bearing. There are some sort of constraint, there is a speed constraint, load constraint, temperature constraint, and we select a bearing based on that. But we have beyond this, because every 5 years research is going to change a lot. So whatever the traditional 1985 things which we have been referring in the books are completely changing, and industry has a much more response for that, because books we can teach, but industry demands we can improve those things also. These are important. That's why we say advance in the materials is important, production methods, control system, engineering approaches, all these are together going to evolve the bearings. If I take even example of the rolling element bearing, it started around 100 years back, and that they have developed. Because I was in yesterday meeting, I was mentioning also, if I want to make a rolling element bearing at IIT Delhi, whatever the bearing 150 rupees you are selling, I'll take even the 15,000 rupees. Or even that will not be sufficient, it will not be able to match the results. So research is something different, but it has to come to industry, and where a lot of research and the combination should be selected. So I'm just trying to give a very example of the rolling element bearing, which came in a Fortune Business Insight. It says that 2018 even it was USD, the overall projection was around $21 billion, and 2026 it will be $26.71 billion. This technology, 100-year-old technology, still has so much progress. Now you start investing money in a magnetic bearing, I'm sure within 15 years, at least 10 to 15 years, we can replace complete rolling element bearing also. So this is what I'm trying to say. Reason being, we learn a lot through the exposure, right? I did one work in the Jindal Iron and Steel. That time I learned that the cage plays a very important role, because Timken companies are also here. I was studying their pin type cage, and escape is also here, and then they were using the brass cage, and we found the brass cage is not efficient enough as a pin type bearings, a pin type cage. And we did analysis for that company, and we reported that the pin type is giving far better results. Even when you change a technology, everything changes. Even the way we need to fix, the way we need to locate, those things also change. It is not the traditional thing can continue with that. So we recommended finally our recommendations to the company, and they were very happy. And I don't know who become unhappy. I don't know, but the overall research went in bigger manner. Now I'm just trying to say, because many people have been talking, oh, magnetic bearing, so many complex circuits, wires, this, that. Now if you look at the rolling element bearing, the way they are manufacturing, now the bearing clearance plays itself a big role there. And this has been taught that bearing clearance comes in only in microns, which I can't do even in IIT now, the kind of manufacturing, right? You look at the clearance comes to something like lesser than 50 micron. Now, if I go with this kind of thinking, and I may say that if there's no standard, what will happen? If there's no standard, your alignment will not happen properly. Even the way assembly you want to make, it will not happen at all. I'll just give you the one example. If I have it's like a misalignment of 0.01 degree, it's not measurable. Unless there is a good standard and kind of equipment which we are going to use to assemble it. 0.10 degree, that gives a 5 micron misalignment itself. And if there is some bearing which has a 5 micron only internal clearance, whole internal clearance is exhausted. After that is only preloading. Now, if it is a 0.1 degree misalignment, it's going to create a more like a 50 micron clearance on the misalignment, which eats away complete clearance. The same bearing, which was ideal, the best bearing, it was performing well, just 0.1 degree misalignment creates a lot of problem. So same thing is happening with the magnetic bearings now. Whatever the problems which we are facing at the R&D level, that can be solved when the manufacturers or maybe industry can get involved on those kind of aspects. So this is, I'm just trying to show some results, and if I simple try to connect with the force, how much force is coming because of this 5 micron misalignment, it gives something like a 42 kilonewton. I selected a bearing only for 5000 Newton load, and just 0.1 degree or 0.01 degree misalignment creates a 42 kilonewton load on that. Bearing can not work, will not work at all. And if I see the coefficient of friction, which are ideally supposed to be 0.0015, it becomes a 0.15, 100 times increase in a coefficient of friction, right? So this is what I'm trying to say. When you think about magnetic bearing and you look at the future, and if you bring industry on the board, I think most of the problems of mag bearing, whatever we are facing, can be resolved, can be solved easily, and this technology can penetrate completely into our real world. Now, let's talk about some sort of, because this is the BIS related and then the invitation. So I had just written one lecture, the one slide only on standardization. I believe that unless we go for standardization, establishing the science, because I can make any bearing size, but what is really more suitable, we know the rolling element bearing comes with a standard size and we select. So don't give it too much freedom. You come up with some sizing, some tolerances, some sort of mounting interfaces, so that it is a two-way communication. Industry person also follows, user also follows, and the person who's designing that also follows. For time being, we don't have those standards at all. It's our wish, whatever we like, we want to design it, that we can experiment it. So that's important for us. Another one is interchangeability. If you buy Professor Tiwari's bearing from his lab and you buy a similar kind of specification from my lab, you will find a lot of change as such. because we don't have those standard to keep fix those things, and then they will not be able to interchange. So that from that point of view, this kind of the fixing standards for magnetic bearings are very, very essential if we want to really, you know, break this TRL 3 to 4, maybe we want to reach to the 8 and 9 kind of thing. Those are the standardization is very, very important for us. And then we need to also keep a check the power requirement, because otherwise we will not be able to solve the problems. Power requirement is essential, even the efficiency is essential. You need to set those rules so that for time being we don't have any rules as such. If you set the rules, research will also move to those directions also. And then another thing, maybe I'll just show the one slide. The newer and newer materials keep coming. Of course, India doesn't have those kind of materials. We have been importing, but again there is a selection. Now, if there is a big demand, those materials will come much cheaper cost. When we buy a few materials or maybe the little bit quantity, it will vary significantly. And if I bring all those aspects, I find enormous application. I don't see any application where the magnetic bearing cannot be used. That's why the Singh Sahib morning says, bearing is everywhere. So you can replace all the bearing with a magnetic bearing. How? I'll just show those kind of things in my, and the way you say that it requires evolving continuously with R&D, and then smart bearing, which is the foundation is coming, the ML, AI and all, those things can be implemented in this kind of magnetic bearing. So I believe if we R&D labs, institutions and industry work together, we'll surely see this kind of bearing into the market. And there are already applications which Professor Tiwari has shown. I'll be showing few applications, and then I believe that it will change completely. Now, number of questions came to Professor Tiwari, so I made this slide thinking that this kind of questions will come. You can see the kind of the load which magnetic bearing can see. So average we will say is a kind of a 0.05 megapascal or probably the on average pressure. More or less temperature should be lesser than 100 degrees centigrade, because otherwise the demagnetization will happen very fast. My efficiency will come down significantly. How fast demagnetization can be stopped by cooling arrangement or making some sort of additional arrangement, that's not possible. Or which kind of materials really can have a high thermal conductivity, or the way we talked about something like a hybridization of with a hydraulic hydrodynamic bearings. So what kind of cooling agent, whether I will be using some sort of graphene nanoparticles to increase the thermal conductivity of the lubricant, of increasing the flow rate, those are possible. We can tune whatever is demanded, right? But ideally it should be lesser than 100 degrees centigrade, otherwise there will be problem. Of course, as I say, the application we can really make whatever you like, but again it will be customized. As Professor Tiwari has mentioned about the instability, or maybe say the control which really requires. So instability is an inherent problem in a magnetic bearing. But question comes, is it only the magnetic bearing? No. It's not. Gas bearing came much earlier than that. Gas bearing has much more instability compared to this. Here we are giving inverse power of the H2, that's a film thickness. While in think about a gas bearing, it's a cubic. That the sensitivity of the gas bearing is much more than magnetic bearing itself. So it's not only the magnetic bearing facing problem. Gas bearing has a more problem, but we have a solution for that. So if we have a solution for gas bearing, why not magnetic bearing? So this is another thing, and somebody who is designing magnetic bearing without thinking the gas bearing, that's absolutely wrong. Because when you go for the high, unless there is a vacuum, air will be there. There will be some sort of transmission, there will be some sort of sharing of the air. So without considering that, that's not possible for us to go ahead exclusively on the mag bearing. We need to account gas bearing or maybe air bearing into the account. So these are the things. While gas bearing, if you have look at the temperature, I can go sub-zero temperature, I can go to 2000 temperature also. Now, if I want to really design complete bearing only for the high temperature, I'll take a lead role, I'll give a lead role to the gas bearing and minor role to the magnetic bearing. So that overall good results, viable results can be obtained. Now, when I talk about the gas bearing, again, it has an enormous problem, but we have solved those problems, and I'm trying to show the analogy. Whatever we have done, same thing we are doing on the magnetic bearing with a new kind of garments to the magnetic bearing. Same thing we are doing exactly for the gas bearing, or maybe the magnetic bearing which we have done for the gas bearing. Now I find a similarity. We require excellent manufacturing, high precision. Even if I go with the nanometer level precision level, then only the gas bearing is going to work. Otherwise not. You talk of the foil bearing, you talk the bomb bearing, we require excellent precision in that. Without that, it is not going to work. And then as I say, the high speed application, gas bearings are more suitable compared to the magnetic bearing. And whichever way we want magnetic bearing to reduce the current which is being supplied, we may use the word AMB like a bias current, that can be reduced when we combine with a gas bearing. However, it has also the same load carrying capacity, low load carrying capacity gas bearing, and the magnetic bearing same thing. They have a worse damping. That's why when we design a gas bearing, we account those things also, and then fabrication cost is very high. Still, we are using gas bearing. It has been in mentioned in this manner. Now here, which the way gas bearing instability dealt, we do, instead of the one single bearing, we make a multiple bearings. And exactly same thing we are doing with the active magnetic bearing. Instead of one active magnetic bearing, we are making 4 active magnetic bearing. We are making 8 active magnetic bearing, which Professor Tiwari has already shown the electromagnet. Whether you have 4 electromagnet, you have 8 electromagnet, what kind of control you have. Exactly same thing which we are doing, which you have been doing with the gas bearing, we are doing with the AMB in this case. Now I'm just showing one of the example. Even we do same thing with hydrodynamic bearing also. The 5-pad tilting pad bearing has been shown is a conventional being used extensively in a number of applications. Now how we can really utilize this kind of technology for the magnetic bearing, that's possible because we already have a technology tilting pad bearing, and here you see the pad is getting adjusted, right? In this case, otherwise what we do, we change the shaft, we adjust the shaft in AMB, while in this case we adjust the bearing itself, right? So it is a relative motion. I can adjust anything. Here the pad is adjusted, there the shaft is adjusted. We can really develop this one. I'll just take a very classical example. That's a hard disk drive. I don't know how many people know. The hard disk drive have an air bearing. And in 1985, enormous money was spent on that. Just to understand what is really happening in this hard disk drive. And simple, the data read and write head has to levitate from a disk, and this levitation is in nanometers. If I increase the space, then the disk size will increase. If I reduce the space, chances of wear will increase. So they use only layer thickness of 3 to 4 nanometer, and they use a read and write head and then levitate it and then operate it in 10,000 RPM also. Right? So these are the typical example where the 1985 onward the solutions are there. So why we are not combining this kind of solution? And this is what I am trying to show the mechanism. So if you look at, this is what a taper roller, we have a levitation over here, and this is a air the bearing itself. And this operates maybe 6,000 to 10,000. 10,000 I have seen maximum in this case. Maybe I don't know recently whether it has a further enhance or not. But this is what things are available. Now how do we control air bearing? Same thing. The way we use magnetic bearing bias current, we use here the aerostatic. We pump the compressed gas, compressed air through the different vents. Now I can design those kind of vents. A compensatory it can be a different kind of thing. It can be ventry, it can be capillary. I have so many designs for that, exactly to match the results. Right? So these technologies are there. So magnetic bearing as such is not there. We are trying to utilize existing technologies, trying to implement in magnetic bearing so that the solutions are better and better. So somebody says it is a completely mechatronics. No. Mechatronics is providing some tools to us, but our innovation, the way we think, the way we act, the way we actuate, they are traditional one or old one also. It's that kind of much difference as such coming. Now, if I compare also, if I compare the DN number, because in hydrodynamic and hydrostatic, DN number goes for the 100,000. While coming to the aerodynamic or aerostatic, it goes around 400,000. While in magnetic, it's a 4,050 only, or 4,500. Sorry, 4,50,000 the DN number as such. So it's not really varying significantly from air bearing. Now, that's why now come to the magnetic bearing. Already the Professor Tiwari has said the passive magnetic bearing, active magnetic bearing, that has been mentioned. Active magnetic bearing, he has demonstrated a couple of already application. So I'm not going to that. Only my experience with active magnetic bearing. We did a research in 2006. We made an active magnetic bearing. We compare, and then we compare initial cost as well as the running cost. And we found something like, it costs around $1,500. If I compare with the conventional bearing, that costs only $15. That's almost 100 times less. Even the running cost, whatever the current we are providing to levitate the shaft, that came around something like a 48 watt, while we found the loss in bearing and conventional bearing was only 7 watt. So we found that we really required some alternative, otherwise it cannot penetrate in the market. And particularly when we are talking about flywheel storage system which requires an abundance, right? Because we want to eliminate the bearing from batteries from the market, because the running cost, the battery is very high, replacement cost is very high, and as well as what will happen to that, whatever the battery you are making, how it will be reconditioned, what kind of waste will be generated. So that's why the good solution which we can look for the storage device, flywheel storage device is the one which is supported on magnetic bearing. So that's why I'm going to present few slides on that. Now, 5 minutes now. Okay, I'll just try to wrap up. So magnetic bearing, there are some sort of hidden facts. We assume that it will repel, and then we tried that this is a shaft inside in the bearing, and there should be levitation as such, and then because of the repulsion force, it should work. However, it works in both. One is a repulsion, other in axial direction it becomes attraction, and attraction creates a more problem. So whatever the bearing wear which we were not obtained and are not able to see in a conventional bearing, much more wear occurs in the permanent magnetic bearing. So that was something wrong. We need to change it. So that's why we change it. At the bottom we require levitation. From top we don't require that kind of levitation. So we recommended this kind of 180 degree and 45 degree arc, and we made the bearing. We published a paper also in IEEE. However, later we found that even little bit change, little bit disturbance is disturbing the bearing again, right? And then we found that this kind of rotor, or maybe say the sleeve, the way Professor Tiwari has mentioned, we required a sleeve to be mounted on the shaft, and this is a 45 degree arc, and we found it really gets damaged. The shaft goes and hammers a magnet, and the magnet being a brittle, it comes in a fragment, and because of that the complete polarity changes, right? It doesn't remain uniform. So you start one crack, that's more than sufficient to break complete bearing, right? So that's why we require some other thing compared to that's what we were making, and that's why we started with the Halbach array arrangement. That's again in published literature. It's basically stacking up the small magnets, and so in that we get maximum radial force and minimum axial force. That's what we have done, and this is available in literature. The kind of polarization direction has been shown. We stack the magnet in a manner so that overall we get a more and more radial, minimum axial arrangement. And I'm just trying to give analogy. Same thing we do in the rolling bearings also. If you look at the taper one, anything, we go back to back arrangement. It can be X arrangement, it can be O arrangement, whichever manner you want. But we do a compensation this manner. That's the same thing which we are doing in a Halbach array. Then we made those kind of Halbach arrangements. We thought we are going to get a very good results, but unfortunately we did not get that kind of results, We again got the kind of wear of the magnets, because reason being still some more thing was required, and that's what we implemented. And we observe also that demagnetization happens in a very quickly. The magnet, whatever the magnetic field initially, after a few rotation, maybe a few hundred rotation, demagnetization happens very spontaneously, and that creates a more problem. And in fact, it was a much lesser compared to the earlier full bearing. We are able to see here the disturbance is not that much high now, compared to the full bearing, but still the damage happens, and then we need to change the magnet also. And you can see here initially the complete wear out was here, while in this case wear is happening at some places only. So that's why we started with a rotational magnetized direction arrangement. Halbach has had number of arrangement, so we had started working with RMD structure. It given very good results. Of course, it gives more and more manufacturing difficulties to us. Now we need to make a magnet which is also radial magnetized, and we don't get so easily these magnets. We need to buy it. That's why I'm requesting industry to participate, so this kind of research can go in much different manner. We had a restriction of a 10 mm shaft, and when our theoretical calculations show that 10 micron will be a best option. So 10 micron, 100 micron, making a permanent magnet is difficult for us immediately, but when the industry money comes and then they start working, I think solution will be there. And this is what I'm just trying to show the results. RMD gives a very good results compared to the other structure, and that's possible. Now if we try to do this kind of research, it will really help. We also did a hybridization with a hydrodynamic bearing, so you can see that instead of the wide span of the natural frequencies, or maybe say the frequency domain, now we get much narrow domain. Right, in this narrow domain we should not operate the bearing, or maybe shaft should not be operated in this frequency domain. Other domain it's possible, because we are not getting that kind of disturbance. And whatever I showed, everything works only for one particular direction, maybe say load and speed condition. Whenever you change, you disturb, then things will not work. And when you require some reliable product, you need to keep disturbing again and again, so that you get a best product in this case. So this is what we have done. And now, as I say, that we really require thinner magnets that will give good results. We worked with N35 magnet. We have also a magnet of N50 we can procure, and we can get a good results. And finally, we did a testing on this. We kept a very big flywheel. We could store energy. We could run for the number of hours. So this is working. But again, if you do little more disturbance, it will fail. But this is what a future for us. What do you say? That at least from storage device, this is a foolproof. And then if industry will start participating, I think almost all the bearings can be replaced with this kind of bearings. So this is what my understanding. And now I was thinking about how to make a 10 micron, 100 micron magnet. 3D printers are available. Printed circuits can be done. I can combine AMB and the PMB together in a segmented manner, what we call a segmented manner. So that is possible with the 3D printing. That's possible. But how much really it will give results, that need to be tested. So hypothetically it is possible, and it will provide a good results. Anyway, I'm just trying to show the last two slides. Many things which initially people thought it's not possible, I'm showing those are possible. Waste management I did in 2017 in Colony, I guess CMERI, still that's working. We don't dump anything outside. And I have been informed now CSIR has given almost 25 crores, so that it should spread to all CSIR lab. At least they should remain green labs. So I'm thankful that whatever I started in 2017, now after 6 years some results are coming. Now this mechanized scavenging system, again people thought in one way. We now have been informed that our cabinet minister is also mentioning that CSR has made mechanized scavenging system. That because at least I have seen in my colony in that time that most of the building are on a garbage, and waste remains, the water will remain there. And finally, that when we have a mob control related problems in Kashmir, so we made 3 vehicles. When I was taking this project, everybody felt that we cannot manufacture, we cannot develop, but this is what is possible. So everything, whatever is appearing today, not possible, will be possible with a consistent effort. Thank you for your attention.
Thank you very much. Such an elegant presentations. So now this question answer sessions. If any questions from. Yeah, please. Please.
Okay, only one question. Mr. Iran, one question from my side, that as you are showing the more potential with respect to the present conventional bearings, what we are using it. So when you talk about the pressure, your slide, you have just mentioned the slide with respect to the pressure coming. The pressure should be very less, and the speed is at a maximum level. So how you can justify the existing bearings which are capable of taking high pressure with respect to this product?
Yeah. So when I started, it was starting like with the AMB, because if you go with more pressure, they require more bias current and more problem. That towards the end, when I came to the flywheel, those things were already overcome.
Okay.
When we were operating only in 10,000 RPM, we did not go to 25,000 RPM.
So if I talk about in terms of the newtons, if I talk about 10 kilonewton is there for the existing bearing.
Yeah, it can be tuned. As I say, now I have a permanent magnet, and I know that a Halbach arrangement can be made, and if we, with industry participation, we can make a narrower magnet and stack up. We can increase the magnetic bearing capacity significantly. That's possible.
This is the last question.
Sir, is this useful only for the high speed and low load?
So that is started with AMB initially, whatever was presented. As I said, towards the end, and when I think about hybridization with other, all possibilities there.
Because the plain bearing generally runnings with the low speed and the high load is requirement is there.
So with the last towards, I say the hybridization, those things are possible. Now, what is a really plain bearing? In my view, again, I'm using only plain bearing. I'm changing the material. I'm changing the material of the sleeve, which is will be mounted on rotor. I'm changing the material of the bearing. That's only I'm doing. Remaining levitation is happening because of the magnetic force. Now, if you want to increase the damping of that, then you can add with the hydrodynamic action also. So your plain bearing, same groove arrangement, same water arrangement or lubricant arrangement, but much more load carrying capacity, no wear and almost zero friction. See, plain bearing, what is the problem? Initially there will be friction, and the coefficient of friction goes 0.25, and the levitate condition goes to 0.005. Right? And because of the instability arise, while in this case there's no touch at all. So levitation is inherently or always available. So coefficient of friction remains 0.005 to 0.005. Right? So that is stick slip phenomena which have been studying or oil with that sir has mentioned, those things will completely get eliminated. Right? So that's what I'm saying, only magnetic, your plain bearing, I'm changing the material. If I want much more controllability or much more damping, or I say I don't want hydrodynamic at all, I'm more interested in mechatronics and sensors and smart bearing, then I'll go with a layer by layer structure. I'll remove hydrodynamic, I'll bring active magnet. Active magnet can be printed also, and then I supply very lesser current, because here the primary will be the magnetic bearing PMB based and secondary will be the AMB. Presently what is happening, AMB is a primary and the passive is a secondary. While what I was suggesting just opposite. See, permanent magnet has a much more potential. You make AMB as a secondary. And in a very close touch, or maybe because of some jerk or impact, shaft is going to touch. That time AMB will work.
Sir, I just want to ask one question, sir. Sir, I want to invite your comments regarding the reliability and the quality of power supply which needs to be used for this.
See, we generally go with a DC supply, whatever current we require. So whatever you are using the system there, that reliability of the system will be the governing factor. If the reliability of the system is very good, the AMB will have a good reliability.
Because, for example, when we use AC current, so
AC current we don't use in this.
okay,
We use DC current.
DC.
But DC, that quality, is there any
Power
specific-
factor has to be very good then.
Yes.
Yeah, that's a one, almost one. So,
We can discuss it over the lunch.
thank you.
Thanks.
So I thank Professor Irani for his very interesting lecture, and just allow me few seconds to load the next presentation. So our next speaker is Dr. Somendu Jana. Dr. Jana has been working in propulsion division, CSIR NAL, since the last 25 years. After his PhD in mechanical engineering from IIT Kharagpur. At present, he is working as the chief scientist and head of propulsion division of CSIR NAL. His area of research work is rotor dynamics, bearings, vibrations, and external dampers for rotating systems. He has also been involved in the area of R&D of turbo machinery of aero engines. He has published 25 journal papers, 55 conference papers, and 30 project documents during his professional career. He has been member of various learned bodies such as Bureau of Indian Standards, Mechanical Vibrations and SOX Sectional Committee, MED 28, Tribology Society of India, Aeronautical Society of India, Institute of Smart Structures and Systems, ISSS, IISc India. He has been awarded National Design Award in Mechanical Engineering for the year 2013 by National Design Research Forum of Institution of Engineers. Besides few other excellence awards from CSIR NAL. So I will request Kulkarni sir to kindly welcome Dr. Jana with a bouquet and a memento. And now I request Dr. Jana to kindly start his lecture. You can change it from this is the lighter and
Good afternoon, rather. It's past 12 o'clock. Good afternoon to all of you. I thank Kundan for kind words and profusely thank BIS. Yeah, okay, sorry. Thank BIS and Tata Motors as well for giving this platform, for sharing our experience. We are working on magnetic bearing and similar activities on that. Thank you all. So, at the beginning, I should say that my job has been reduced because already you have listened to lecture on the magnetic bearing. So, advantage is I can skip many slides in the beginning. So, that is the advantage. So, layout of presentation is like this. Basic introduction. I'll skip whole introduction. We already you are aware of that. What is magnetic bearing? And but still, I wanted to touch few aspects like. Force and stiffness characteristics, we should more concentrate on that. A lot of things to be worked out on that to make it a successful industrial product, basically magnetic bearing. Then actuator design, I like to touch upon. We have worked a lot on that because magnetic bearing has many, mainly four major areas like sensors, controller, power amplifier, and actuator. So we'll touch on actuator design. And a few case studies what we have done through sponsored project, particularly with IGCAR, nuclear power generation industry. Introduction I can skip. Basically, you know that two types of bearing. There are many industrial applications also, and classifications already. Professor Theory has elaborately explained different type of magnetic bearings. Although this is shared from a textbook, working principle advantage I'll skip. As I was telling, basically 4 major components in active magnetic bearing: sensor, controller, power amplifier, and magnetic actuators. This is true for active magnetic bearings. In case of passive magnetic bearing, we don't need sensor or controller or power amplifier. This construction wise, that is much simpler. Here, to start with, some basic formulations I wanted to show to explain why active magnetic bearings are inherently unstable and why we need a feedback control. So, this is a basic very preliminary configuration of active magnetic bearing. There you can see in vertical direction 2 actuators in either side of the rotor, and in horizontal direction also 2 actuators are there. So, one simple configuration is, so suppose that rotor, if it kept at the center and we activate the magnets, it does not stay there. So, there will be minor deviation in the forces, and either it will go in one side. So, to counter that, the controller's job is to keep the rotor at the center. So, to do that, controller will do current adjustment in top and bottom side of the actuator, as well as both horizontal side. In the pictorial, it has been shown here. And if we express the forces acting on the rotor, it looks like this. As already you have seen that a force is proportional to I square by gap square. This is the other parameters are like permeability of the medium, and then actuator cross sectional area and number of turns. These are the major parameters. And we it is comfortable for us, suppose we want to do some simulation model, we need to linearize it, and if we linearize that, so it takes this shape. So, here in y direction forces are termed like this. So, here you can see these are current dependent forces, and this is gap dependent forces. There are 2 distinct group of forces acting in a magnetic bearing. So, you can see, if we go to the stiffness, basically we are all mechanical engineers. To design a bearing, we want to know what is the stiffness of the bearing. So, that it can be grouped into that, and as it is an active feedback control systems, the current can be replaced in terms of gap as well as velocity of the gap, basically first derivative of the gap. So, this we normally call it as proportional stiffness factor, and this is derivative stiffness factor. Integral we are not considering in this for the simplicity, sake of simplicity. Now, all this replacement, finally we get the force expression like this. Here you can see this part is positive and this part is negative. So, this will result into positive stiffness. Suppose if you wanted to evaluate stiffness, sorry, like this, kx is df by dx if you do a simplistic manner. So, this part will result into positive stiffness, and this will result into negative stiffness. So, I normally conventionally will call it, this is a positive current stiffness or positive stiffness of magnetic bearing, this is negative stiffness. So, this inherently negative stiffness, we know that any system it becomes unstable. That is why if feedback control is not there, this part becomes 0, then your magnetic bearing is unstable, it goes to any one side. To counter that, we introduce feedback control, and that whole thing we wanted to bring it to a positive side. So, then somebody can think that if I increase this gain very high, so we will get very high stiffness, but that also has a penalty that we can see here. If we plot the stiffness versus rotor gap, here you can see for very high gain, we are getting stiffness versus rotor gap parameter is like this, characteristics is like this. From here we can see the moment this curve crosses 0 line, this region the bearing becomes unstable. So, we cannot increase the stiffness as we wish. So, there is some optimization. So, here very low stiffness, we can get a wide range of stable operation of the magnetic bearing. But in that case, stiffness is low, so we cannot take large load. So there is penalty. So we have to do some design optimization that I wanted to bring to you. And one more thing, this is for horizontal bearing in horizontal direction characteristics. It's very ideal and symmetric both sides. Whereas in vertical direction, because of presence of gravity, this is not symmetric. It's unsymmetric. So now the designer's job to do a perfect design or good design of the bearing, he should do a lot of optimization and should understand the nonlinearity effect of the forces in a magnetic bearing. Okay, that I wanted to bring. Now sensor, okay, you know that there are different type of sensors. We can measure rotor gap, then controller also can be of different type, maybe analog controller or current day digital controller. Lot of improvement has happened. We can utilize the advantage will be we can implement very complex control algorithm if we use a digital controller. And power amplifier, from power amplifier point of view, your magnetic bearing can be classified into two types, like we can voltage feedback type power amplifier or current feedback type power amplifier. So both has some advantage and disadvantage. So current feedback type power amplifier basically, I need sorry. And current amplifier type feedback control power amplifier, if we use that advantage is it is simplified in implementation. Actually, in case of voltage feedback controller, it becomes little complex. Controller design becomes little complex. Then digital power amplifier also nowadays available for different. Pulse width modulation, plus there are many other advanced digital power amplifier also available, where loss of power will be much less as compared to analog. And analog power amplifier, another disadvantage is currently available power amplifiers, current limitations are there. So we wanted to design magnetic bearing for high load capacity. We need to have higher current capacity power amplifier, that is the limitation. Whereas digital power amplifier, we can go for very high current level, 100, 200 amps current also it can take. So different configuration, as Professor Tiwari mentioned, that actuator basically can be homopolar and heteropolar configurations. So there it can be conical also. So heteropolar, homopolar already explained by Professor Tiwari. And now if designer should look into the performance of AMB, particularly we wanted to see that in dynamic situation, how AMB can support the rotor loads, basically dynamic load capacity. That depends on a few parameters like actuator cross section area, then peak current voltage of the controller, and other few parameters are there. Mathematically you can explain, this graphs explains very nicely. Suppose this is dynamic load capacity of the actuator. The moment we are operating at higher frequency, basically higher speed of the rotor, so drastically that force comes down. So we may be designing a bearing for a particular load capacity, but as the speed increases, its load capacity decreases. And what factors does that? Basically inductance gives, that is the main culprit for reducing the dynamic load of a magnetic bearing. So to avoid that, we need to design magnetic actuator basically whose inductance can be as low as possible. Okay, but if inductance again depends on cross sectional area and number of turns. So if you wanted to have low, so we need to reduce area and number of turns, but that is again problem, your total load capacity will reduce. So all this, there are different type of optimizations are there. Actually, we did some experiment to design actuator which can have higher dynamic load capacity. So we found out that if we have multiple coil actuator technique, so multiple coil means in same actuator we can have multiple coil. Then in number, basically we are dividing n Suppose if we have a single coil, N is 100 turns. If we have 10 coils, the N becomes 10 turns. Then basically it becomes 100 times less inductance, then your dynamic load capacity will increase. And this has been patented also, and we have used this for one of the high speed magnetic bearing design. I will show you in the later some application. So here you can see at different frequency we have captured. Basically, we are asking some force to be generated by the actuator, but actually there will be phase lag. And if phase lag happens, that is very detrimental. And if it goes more than 90 degree, that itself will destabilize the system. So all these factors designers should consider when designing actuator, particularly for high speed application. Here you can see for 90 hertz, such a large difference for jumping from, for using two coil system as compared to the single coil system. So if we go for multiple coil system, we can get much more advantage in terms of dynamic load capacity. So this I wanted to bring to your notice. Then I'll talk about case studies. Quickly, I'll try to complete these things. Here, basically, we have worked almost 2-3 decades on this in National Aerospace Laboratory. One group is working. After my PhD, I joined that same group. So first project was done in NL was 5-axis levitation. This was supported by AR&DB. So we thank AR&DB also because we get some seed funding for research. And it's a typical Jepcot type rotor, 2 bearings and 1 disc type. And it's a complete passive levitation. Passive levitation in the sense, and subsequently I'll talk about sodium pump prototype vertical rotor. We have gone into different steps of design. Then we have done demonstration of 30,000 RPM 10 kg rotor for GTR one gas turbine engine application purpose. Also we have done some magnetic bearing design, and finally one demonstration on passive levitation. That is a combination of basically foil bearing and passive magnetic bearing, where somebody questioned that controller we can avoid fully. So that also you could demonstrate up to 40,000 RPM. That is a specific application I'll talk about later. In this is very old, maybe around 2002, 2003 we had designed that thing. Even if we have demonstrated that this rotor was around 10 kg rotor, and it has run up to 10,000 RPM. We have demonstrated that video. I'll hope that video will work. And few features are there. We know that. I'll skip these things. So here, this magnetic bearing, this is off condition. Moment we switch on, this is the reference. 0 line is the reference. You can see that horizontal controller basically bringing the rotor exactly 0 line. Whereas in vertical direction, it's some offset is there. This is because to counter the static load. So, and you can see the controller, it stabilizes within short, maybe few milliseconds, it stabilizes the system.
Dr. Jana, only 5 minutes.
Okay, I'll quickly finish it. So I'll go through these basic things. I hope this will run it. I can run from. This is a demonstration. Okay, I'll skip this. This was done that time, and then we are looking for application. Then fortunately in 2003, I hope in December, Process Theory organized one national symposium rotor dynamics in Guwahati. There we could meet IGCAR scientists, and they said they need magnetic bearing for sodium pump. They are basically conventional bearing lubricant. If leaks to the liquid sodium, it's a catastrophe, and some cases has happened. So then we interacted with them, and fortunately we got some funding from them. Their specifications. The actual full-scale vertical pump is around 11.25 meter, huge, and around 8.4 ton total rotor weight. So we thought we cannot attempt that at the first stage. We have to go in different stages. So first case was this. They had a prototype of that pump, which was around 100 kg, and height was around 2.2 meters. So. And we can compare this. This is the prototype pump. Test setup was there in IGCAR, Kalpakkam. And it's exactly same thing. We have to retrofit the magnetic bearing, basically radial and thrust magnetic bearing to be retrofitted. Basically geometric dimension, what was available space, we have to fit it there. We have designed and we have demonstrated also. And bottom was this hydrostatic, hydrodynamic bearing, basically hydrostatic bearing. And these are the various challenges was there, so we have come across, and here kind of distributed control actually we have adapted here because a huge disc, And if we use, we can basically, ideally, a single sensor should capture in one movement, but we have to use 4 sensors, because in one sensor, no, if tilt happens, it cannot capture that. So to capture the tilt, we have placed 4 quadrant actuators and multiple actuators and 4 sensors. Kind of distributed control we have adopted. After that only we could demonstrate these things, and radial bearing was not so challenging. And this was the test setup photo, and some of the rotordynamic analysis results are there. Hence, it was, and some critical speed was there somewhere before the final speed was up to 2,900. That's why we can see one peak here, and some vibrations things. Okay. Maybe system dependent. Okay, we'll see towards. Then the second project for them, we did actually scaled model, because we have to attempt for full design of the bigger system. So bigger system has been scaled to a rotor, which this is the configuration of the rotor. The idea was, if we can demonstrate in this scale model of the full system, so whole design can be transferred to the full system. That stage has happened, and we have demonstrated also this one. Then all designs are ready. So we are waiting for some funding. If it comes, we can try to work on that to develop magnetic bearing for the full system. And this is basically, I was talking 30,000 RPM, one rotor, around 10 kg rotor, GTRE, one engine they are developing. One single stage rotor is around 10 kg. So that for that magnetic bearing, speed is around 30,100 or some speed. Idea was, initially we can develop magnetic bearing, and for balancing purpose they can use this rig. So we could demonstrate that. When actual aero engine application, still lot of reliability and other things, we have to sort it out. Then only we can think of applying in engine things. And this is the last demonstration I wanted to tell. This is complete passive levitation. So here you can see this is a passive magnetic, as Professor Hirani was telling, hallback arrangement. So we can get stronger magnetic field, and for smaller size we can get larger forces. This supports the rotor in axial direction. So because of Earnshaw's theorem, then radial direction becomes negative, unstable. So to support in radial direction, we used passive, foil journal bearing, and this we could demonstrate up to 40,000 RPM, and this, we have reported also this in journal, IMEC journal paper. So yes, there are few basic conclusions. And one thing, because it's a standardization platform, no, I wanted to, maybe magnetic bearing, as we say that it should be customized. We can go in modular approach, like actuator can be one module, controller module, and each will have some range, and customer can select the module and fit it to his application. Maybe that approach we can take in when you are going for standardization. Thank you so much for your attention.
The session is open for questions. Only 2 questions will be taken. Any questions? Yeah, please. Although I was not encouraging academicians, but now I am helpless.
This regarding the, I think you talked about the optimization of the stiffness with the gap. So that is the variation with the bias current. Your 3 curves were there.
No, gap. So
The gap is the horizontal.
gap and feedback gain, proportional gain. I can.
Yeah.
So
Okay.
yeah, I'll open that thing.
Yeah. So gain, how you are getting? You are getting from the bias current.
Gain, we can get, gain is, we have to consider full path, like sensor
Okay.
also will give one gain.
Okay, everything.
Controller also some gain will be there, and bias current obviously it contributes the majority of the gain.
Okay. But you are talking about linear stiffness coefficient.
Linear stiffness coefficient, yeah.
No. But you said ki
That
nonlinear
is for
effect is-
nonlinear forces and nonlinear stiffness. Wanted to see that how nonlinear, that is the actual. If you linearize, it will be throughout the gap, a single stiffness value.
Okay.
And we use that for modeling purpose. When in practical purpose, it doesn't happen like that.
Okay.
We get much smaller zone, stable zone, operating zone. If you use actual nonlinear stiffness, if you use in the model.
Yeah. So you are proposing gain dependent stiffness?
Adaptive gain rather. So depending on rotor position within the gap, we can change the gain, feedback gain. So that is possible if we use digital controller kind of thing. So that we are proposing. In fact, we are working on that. I mean, we published 1 or 2 papers also on that. Basically estimating nonlinear stiffness of the bearing based on the position of the rotor within the gap. So that.
For the bearing system which you are talking about for the sodium,
Yes,
doesn't sodium liquid sodium, doesn't it get affected? Doesn't the liquid sodium environment
Yes, sir.
affect the performance of the bearing, magnetic bearing system? Or it is completely sealed from the medium?
Sir. Here they have, actually, if I go one step further. Here, they will have one cover, argon cover will be there, some region.
The whole system is totally sealed.
Sealed, yes. Sealed from sodium vapor will not come up. Because otherwise it's a very corrosive environment.
Thank you very much. So let's give a hand to Dr. Jana. Just to summarize the session, I don't want to stand between you and the lunch. A short summary. So this was a very good introduction to magnetic bearing, along with its classification, possible applications, and also other important characteristics like stiffness, etc. So this has given us an impetus that we should definitely have an exclusive committee in BIS for magnetic bearing. But that's irrespective of what is the stand we take in ISO 123, if I remember correctly. But there are few areas which I think we'll not discuss now, but that will be discussed in the discussion session, and in which our manufacturer as well as users have to be very active. So what are the areas where we can have immediate usage of magnetic bearings? Which all application we can immediately bring magnetic bearings? That's a very important thing. And also probably inadvertently, Professor Hirani touched upon another interesting area, which is magnetic bearings for micro electromechanical systems. I'm not sure whether it is a feasibility, but that is also one thing people who are working in the research area should keep in mind. So I would like to conclude this session. We have a lunch now. Let's join for the lunch so that we can immediately start our second session. Kundan, what time we will be back after lunch?
And we are planning a 40 minutes lunch. So it will be 3:50. Sorry, 1:50.
Yeah, I think 2 o'clock is enough. Please be back to the seat by 2 o'clock. Thank you very much.
Actually, we have memento for all the speakers. He is leaving.
Sir is leaving, that's why they are pending.
नहीं आप आ जाइए ना दोनों का ये भी नहीं छोड़ो 2 मिनट में तो काम हो जाएगा You represent. I see if they have one company, then they will have एक बार उन्हें से बड़े पूछते हैं
Okay, gentlemen, I think we will be starting the second technical session, and I will request everybody to come back to their seats. Uh, So in this second technical session, we will be focusing on automotive bearings and aerospace bearings, basically railway bearings and aerospace bearings. And again, in this session, each lecture will be 30 minutes long. And for this session, Dr. Joseph will be chairing all the lectures, and he will remind the speakers when the time is about to get up, and also he will be concluding the session. So without any further ado, it is my honor to invite our first speaker, who is Sri Guru Raj Gaddi, working as DGM, Product Engineering Railway in SKF India. He is a mechanical engineer with post-graduation in tool design. He has 20 years of experience in automotive and railway industry. He worked in BIW body design, vehicle integration of automotive and architecture of design of metro and regional railway platforms. He has vast experience of working on railway projects of Europe and Southeast Asia. So, first of all, I will request Kulkarni sir to kindly welcome Guruvaz sir with a bouquet and a memento. And now I will request Guruvaz sir to kindly start his presentation, and somebody can please turn off the front lights so that the presentation is visible more clearly.
So, hello all. Good afternoon to you, all of you again. And I welcome you for the second half session, which is always post-lunch heavy sessions. And I am given an opportunity to speak about railway bearings and emerging trends and standardization. So, firstly, I thank BIS committee and Tata Motors, who is facilitating here, and also Dr. Manish Roy and professors who has given a brief lecture and detailed informations about magnetic bearings. Before I start out, I want to comment on few things, especially scholars when they presented the magnetic bearing researches. Now it's a time for bearing manufacturer like us. Maybe we have Schaeffler, Timken, SKF as a bearing manufacturer. How to converge these ideas, or you can say the researches, into product, that too in a scalable manner. So that is the key things which we need to work out, because magnetic bearings are the one which we see in the scope of 10 years or 15 years in the next coming time. They would be the real products which are in the need of market. That's the point. And second, I want to go on with the railway bearings emerging trends as a subject. And here, when you can see the agenda, me from SKF as well as Timken were given in the same subject. Then we thought of why not to have a look on each other's subject, so that we should not bore the listeners, or you can say the contributors. So in this concept, so what I am going to brief you mainly on the past of railway wheel set bearings, because you would have heard about only bearings, but what is all about wheel set bearings, and what is the present market situation of railway wheel set bearings, and what are the railway standards, and lastly about the emerging trends of railway market. So these are the four subjects which I am going to speak about. And during yesterday's discussions of BIS as well as committee members, actually there was plan to have progress towards standardization of bearings testing, which of course is going to happen later with the RDSO, who is a main conveyor and governing body for railway bearings. So with that presence, we plan to have it. So with that note, Maybe you can see on the screen quite an interesting picture wherein railway axle bearings, when they are started in way back 1900, so they were all plain bearings. There were no any rollers or there no any special technologies at that time. So of course it used to be a high friction and high heat generating inefficient solutions which was being started. To a present scenario, maybe in India, if I say ICF, who makes Indian coach factory, which makes Vande Bharat, where the expectation of speed is 200 kilometers with aluminium bodies. So what I want to say here is about how inefficient way of bearing wheel set progress has started and how we are at now. Maybe in coming future, when you see the government of India projects where they speak about high speed rails, which is already in progress, so maybe we will go for new technologies which is already been worked by Japanese counterparts, rail makers. So this is how the evolution started, and you can see these are still some places like railway Cambodia uses such type of plain bearings. Of course, the intensity of railway networks or you can say the usage of railway networks are quite low in those countries, but emerging countries are in a transformation phase from such type of plain bearings to different technological bearings, or you can say the smart bearings. You would have heard this smart bearings terminology during morning sessions. So the smart bearings are the customer voices nowadays. So it means it should not only perform as a bearing or a bearing unit, it should also sense and give the customer clear information when I am going to fail or when my life would be ending. So this gives a customer a clear picture when he should be ready with the downtime or prepare himself for the downtime. So that's, I call it as a smart, and this is the present time. So again a slide from history wherein the plain roller bearings, how the evolution happened from 1903, where the DWF, the Deutsche organization, started out to grow with deep groove ball bearings, which they call as a DGBB. Now it's reduced to a smaller shapes, sizes. So it used to carry like 33 tons with higher bearing loads. And after we go with rolling elements, this has been reduced with 86%. So this was a first like a transformation phase, how it has been seen. Some of the pictures of old drawings where the DGBBs or roller bearings or spherical roller bearings. So this is how the evolution has been started. Here I want to show about the last 100 years of railway axle bearings, how the evolution has happened and where are we. Like a primitive solutions, would have seen the DGBB, a basic ball bearing units, which you would have normally seen now in the wheel, automotive two-wheelers. So those all areas you would have seen DGBB, self-aligning ball bearings, which is the main properties which has been started out at that time. And they shifted slowly during 1950s to 2000 with bearings as a bear. It means they are not as a bearing units. So what is the difference between normal bearings as well as when compared to bearing units? So bearing units comes as a complete set. I will show you in pictures now. So this is a transformation where the optimized solution with the tapered roller bearings which is used in the wheel set, which we call as a TBUs, and cylindrical roller bearing units which we use in the drives, and compact TBUs which again used in wheel set bearings for different wagons, or you can say the passenger trains. Maybe before I go, I want to show a picture how actually the TBU looks like. The TBU looks like as a, why I am saying this as a unit, because it comes as a double roller taper roller units with the grease and with the clearly adjusted seals, and you can say a cage which accommodates the rollers. Interesting thing is customer nowadays, or you can say after TBU been in place, they want a higher maintenance intervals and they don't want to grease it. Jitna chalna hai chalna de, and the expectation is up to 1.3, 1.6, and now they are expecting 1.8 million kilometers with no grease change, or you can say no any checkpoints, with maybe a few refurbishments in between. Other than that, the expectation of life is very high from rail makers, and it turns us, a bearing manufacturer, a more responsible way to choose, or you can say a design in how best we can accommodate on materials which could be cost effective, how to choose a greases which should be having a longer life, how the packaging, or you can say the rubber seals which are part of this to avoid a dirt entry can be, because it contributes to the performance of TBU. So these are the challenges we have in front for the railway products, and yes, we are doing different researches at our end. We are taking a fellowship inputs from different scholars how to improve the performance of this TBU to increase the maintenance interval specifically. So just to show you how the evolution or the product standardization comes into picture post 2000. You can see with the standardization, when I say I put it out into 5 different verticals. First is about the design optimization, which how the different configurations are being done with various sizes. Here, when you compare with the railway bearings or industrial bearings, or you can say the magnetic bearings, which was, they are all customized, specific to an industry. But here, they are more generalized bearings where the customer clearly gives only 3 informations in his technical documentation, mainly saying, my axle tonnage is this much, I want this as a life cycle cost to me, and this should be the maintenance interval which I want, which is highest. With that technical informations, when we quote from our organization, different organizations, when we quote, we should be competitive enough to address all these 3. Then only we will be getting a tender and we will work on that. So this is how, yeah. Which one? I don't get your point. Yeah, okay. So, okay, the requirement for any rail makers, or you can say rail customer, is mainly the axle loads. Okay, second one is the life cycle, LCC, and third one is a maintenance interval. So these are the 3 requirements generally rail maker throws at bearing manufacturers. So I was speaking about the design optimization, how we can do. Second one about the component optimization, where like when you see 15 years back or maybe 10 years back, the cages which I shown where the rollers used to fit used to be in a brass or steel cages. And now considering the challenges of cost as well as optimum performance, we replace them with the polypropylene cages, or you can say plastic cages in simple words, which can accommodate, which can be good enough for the loading, which can be good enough in the temperatures which are been arising at that situation. So it's optimization. And lubrication, of course, the different type of greases we are using, and we are optimizing the commonized greases across the industry, which can be cost effective. Lastly, refurbishment, and mainly when I come about the manufacturing optimization, with this all leads to a tapered requirement to make it as a standard which emerges as EN 12080. So when I attend this BIS committee, one thing I feel pretty that till now in the railway industry, because we are having a railways at least since 100 years with the British laid the foundation, we don't have our own standards, railway standards. Until now, we are completely dependent on AAR, that is American Railroad standards, or EN standards. These are the only 2 verticals of standards which we are hanging upon, and we never build our own standards. How to test these bearings, what should be the specifications? No, we never. Maybe this is an opportunity where I really thank BIS team has looked and had a strong consideration to have this standardization to be done, or you can say the standard has to be built for railways, and it's a good move. Of course, it takes a longer lead time to develop such a standard, because it not only speaks about the freight, or you can say the transportation of goods. It also speaks about safety. It also speaks about passengers, where the human life is involved. So we should be very critically examine this standard and make this standard available for forthcoming Indian Railways future. So next I want to move with where are we with railway wheelset bearings, and what are the expectations of rail makers, or you can say the end users. You can say in Europe there is a trend, like rail maker is different and rail operators are privatized there. But like example SNCF in France, who operates for the Europe rails. Here it is not the case, of course. Here the whole sole responsibility is Indian Railways on the main line. But of course, there is a slow trend change where you see different metro corporations, Lucknow Metro Corporations, Chennai Metro Rail Corporations, who own the responsibility of managing the product on their wheels as a metro platforms. But yes, mainline still we are under government observations. And I don't know what's the thought of government in future on the privatization or maybe other aspects, or a private rail maker to come in. So what's happening in the railway industry? When you see the picture, it shows a rolling stock market. When it is being distributed, it's into 4 quadrants. Mainly the high speed rails, metro, and you can say the tramways or the freight. So generally, whenever we split out this rolling stock, it is majorly heavily goes for the related to the metros, as well as next is about the freight. So you would have seen the freight requirements, or you can say if you would have heard some forums when the railway minister says how the freight capacity is planned to increase. Not only with respect to number of wagons, but also the tonnage. Previously, the tonnage of freights were quite less, around 15, 17 tons, 18 tons. Now, in forthcoming time, the expectation is around 25 to 30 tons. So it means that more capacity has to be built for wagons to take on more bags, or you can say more luggage. So what is happening in the industry? Urbanization, localization, supply chain certification, aging train fleets. Now maybe you see in course of time the blue coaches which you are running as a LHB coaches will be slowly replaced with the modernized coaches. You would have seen, or you would have traveled there. The coaches are getting reshaped, and more of ICF, or you can say ICF is inducing, or you can say the Vande Bharat are getting induced for a duration of around 12 in the span of up to 10 hours of normal journey. LHB is being replaced with the aluminum body, or you can say the modernized ICF coaches. So this is how the trend of railway industry has been emerging now in India. And of course, when I speak about railways, of course, operators as well as OEMs have their different view. That's operators have the tailored maintenance performance, maximize the uptime, reduce the downtime, improve the environmental impact. OEMs who makes the rails, of course, they have the challenges to give or accept more customer requirements, technical specifications. So it's quite interesting. Just I give an example. I was working on a metro project for Mumbai. There, in the technical specification, when we were going across to submit our tender detail, tender responses, the requirement was the underbody or any underframe equipment should not fail when the water level from the ground should be up to ground can be up to 3 meters. That was a requirement which was never been seen in any other metro projects. although there are some elevated corridors or ground corridors, such a requirements are there. In that case, your bearings, or you can say drive units, should be self-sufficient, or you can say IP protected for this water entries and water ingresses. What I mean to say is how the OEMs are changing their requirement or modernizing their requirement. Okay, so next about run longer with the confidence with reduced minimal TCO, that is about cost of ownership, and choices to improve environmental impact, wherein reduce energy consumption, reduce waste, and increase service life. And how these points are really affecting the railway industries. So they really help us for three factors. One is about early failures are being detected, focus on the reduced life cycle cost, and lastly the new technology and work progress. And these narrow down to a reliable bearings which run longer and longer. And this is possible only with the standardization, which is presently what we are following, like EN 12080, which is a parent one, and with the two other standards, sub standards, 81 as well as 82. Now I go quickly touch upon the railway standards. So when we say about railway standards, related standards, they can be classified into four. That's the worldwide standards, wherein UIC and ISO are the governing bodies. Regional standards, as I speak about the EN standards, TSI, AAR, where we are dependent, GHOST for Russia. And supplier standards are also been there with the Siemens, Bombardier, Alstom having their own specifications and standards. And lastly, the end user, Deutsche Bahn, China Railway, SNCF, RDSO were for India. So they also have their own level of standards for governing the railway operations. It can be bearings or it can be other systems. So mainly I skip slides of what is ISO standards or what are the USA standards, but I want to touch upon the EN standard, which is a backbone are presently referred by bearing industries. Mainly it speaks about 12080, which is the overall manufacturing standard, and 81, which speaks about the characteristics and test to be respected for the greases and journal bearings. And lastly 12082, which speaks about the test rigs. Maybe just to give a glimpse of testings, what railway bearing manufacturer we have. Maybe we are around 5 different manufacturers who supplies for railways now, and rarely maybe 3 bearing manufacturer has a rail test rigs. And SKF being in the in India for 100 years, which we celebrated, we are going for the test rigs now. Okay, so of course with respecting EN standards, so this test rigs are very minimal in India, and yes, in course of time it would be improved, and we can control the specification when we have the ownership of testing here. And again, this is about, and I speak about the emerging trends, which I just touched upon with some few words. When I say about a railway product portfolio at a glance, I just shown in a picture in a generalized way about the bearings, the traction bearings, gearboxes, wheel set bearings, as well as swing bearings and axle boxes. So mainly understanding the right data is a key for us. Understanding the requirements, increase the reliability, extend maintenance intervals, lower maintenance cost, and reduced emission. So presently, maybe we know Go Green is been really been pushed by the government for many of the organization, and yes, SKF, which I represent, really look for this reduced emission, and Go Green concepts are being taken care. And just maybe you can Google out SKF site. We also give a customer a detailed information. When they choose a bearing, they will get out the information of how much carbon content is been reduced when you use that application. Means to make that bearing, how much carbon is been contributed. So carbon contribution ratings or carbon contribution values are being given in our brochures. Whenever you have time, please go across. So this is about how intensively we look for the go green options. And lastly, about the railway bearing evolutions. So Insacote bearings as well as the ceramic bearings are one where the emerging technologies are work in progress, and some we have already supplied as a SKF to Vande Bharat for the drive bearings, who really part of the electrical drives and give a better performance when they go with the increased uptime and railway equipments for the by reducing the electrical shorts, or you can say the electrical intensity in a reduced way. And lastly, this about the SKF monitoring system. One of the product I want to showcase how the IMAX rail, one of the product of SKF, which detects and mainly checks the temperature as well as bearing vibration monitoring, and it gives how the complete data to customers so that they can foresee downtime, or you can say the failures. So this is one of the product which we have, and I'm happy to declare that SKF is first company which has implemented this conditioning monitoring in Delhi Metro Rail Corporation, and it's been validated. And lastly, turning into data into action, how this works, a glimpse I want to give about how the data onboarding is been captured with the clouds, and how it has been helpful for the fleet availability to check, as well as green, go green, or you can say the carbon footprint are been assessed, or lastly maintenance intervals optimization and bearing performances. So that's it from my side. So if you have any questions on TBU or railway bearings, maybe I can take it out.
Yeah, at the outset, I will thank Mr. Gururaj for his very informative presentation. Now you can ask questions.
Yeah, I'm Jayanta Chakravarti. I'm from Tata Steel, Tata Bearings Division.
Yeah.
And thank you very much for your very insightful presentations. Just like to know one thing, and so obviously you've given an advancement in terms of smart bearings, but I would like to know the very basics. What are the type of bearings that has been actually used in railways? I mean, is it only taper roller bearings or ball bearing? I mean, DGBB, or is it a bearing set? I just saw a picture of one of them. Is it the only one, or basically the variants of this, or there are other types of bearings as well?
Okay. So just to touch upon, you say about DGBB. DGBB were around 50 to 60 year old
Deep groove ball bearings, yeah.
Now we the complete railway bearings are been shifted, or you can say the wheel set bearings are been shifted with the tapered bearing units, which has a higher capacity of tonnage, maybe around 15 to 20, sometimes for the freight up to 30 tons of load, axial loads.
Okay.
They can take.
Okay.
So that's where it's been transformed. Of course, we have roller bearing units for the drives, which you have seen. Mainly the INSA coated, or you can say the coated rollers, which will be helpful for the electrical drives for the grounding.
So I have seen actually two variants here in your probably third or fourth slide, where you're saying TBU/CBU. What is CBU?
It is CRU. That is
CRU. Sorry. Okay.
This is a
Cylindrical roller bearing unit. So basically there are two types of bearing units that you're saying. One is the taper roller bearing unit and the cylindrical roller bearing units.
Cylindrical are used for the mainly for the electrical drives, where the axial load capacities are less.
Okay.
Because there is no any purpose of axial loads, but the TBUs are the axial load taking members.
So can you just help me, if there are any literatures? You have been saying that there are some standards and there are no Indian standards, and it is very important that we include the standards of Indian Railways in the PIS, and probably that is the reason why we are sitting here. But is there any, what you have just said, probably based on your experience, is there any literature or standard which actually explains this railway bearings, what type of bearings, axial loads, higher, lower, or something like that?
Yes, so that's what I have shown in my presentation.
Okay.
There are two base standards which
12080 and 120.
and AA.
Okay. Okay.
These are the two standards which I can show. They are available in the common platforms.
Okay.
So we'll give opportunity to next person, sir. Okay. Anybody? Any question?
Yeah, I'm Dr. Tiwari from IIT Guwahati. What is the scope of the spherical roller bearing? Is whether that because here misalignment you are I think trying to stop. So that is the reason you are not going for spherical.
Yes, that is the main reason why the spherical roller bearings are being shifted to tapered roller bearing units, where you have two sets of rolling units with a common space.
So one more thing regarding the clearance.
Yeah.
When you assemble,
Yeah.
so whether they have clearance
Yes.
between the ball and the races in the
Ball-
taper roller bearing.
Ball and races, they exactly what you are.
Means like ball bearing, we know is having some clearance always, but taper roller bearing, whether initially when you assemble, there's a totally tight fit or there is a clearance between the rolling element and the races. It is.
We can shift the further questions to question and answer sessions, I think. We can go for the next presentation. Thank you.
I thank Guru Raj sir for a very interesting presentation on railway bearings. And the third lecture will again be on railway bearings. But before that, we will have one lecture on aerospace bearings. And for that, our next speaker is Dr. T.H. Gonzalez. He is presently serving as Chief Engineer Design at the esteemed Aero Engine Research and Design Center of Hindustan Aeronautics Limited. His expertise is in the field of rotor dynamics and aero gas turbine engines. With a remarkable career of spanning over 20 years, Dr. Gonzalez holds a PhD in rotor dynamics and has garnered extensive experience working in esteemed multinational companies and prestigious organizations. Dr. Gonzalez has been instrumental in spearheading noteworthy projects, including the development of award-winning auxiliary power unit for AN-32, which received the prestigious Raksha Mantri Award in recognition of its indigenous technology advancements. His remarkable contributions extend to various aero gas turbine engines such as LCA Tejas and the widely used Sakti engine, wherein he has played a vital role in rotor dynamics analysis and project management. Dr. Gonzalez's expertise has been sought internationally, as evidenced by his participation in rotor dynamics analysis projects during his deputation to esteemed organizations such as MS Pratt and Whitney in the United States and MS Turbomeca in France. Additionally, he has been actively involved in vibration troubleshooting for diverse production engines, test rigs, notably including the vibration analysis of LM2500 power plant on onboard INS Vikrant, an endeavor carried out just months prior to its dedication to the nation by the Honorable Prime Minister of India. So, we are privileged to have Dr. Gonzalez with us. I will request Kulkarni sir to kindly welcome him with a bouquet. So I will request Gonzalez sir to kindly load his presentation and then we will start the lecture. Slippery, yes. This one? slightly gone into presentation mode somehow.
Good afternoon, all. To all. As a member of Bearings Sectional Committee PGD 13 of BAS, it's a privilege for me to today present presentation on aero gas turbine bearings. And I thank BAS for giving me an opportunity for that. Per se, HAL does not design bearing or manufacturing bearing, but as a journey like development of a gas turbine engine or manufacturing process technology transfer, usage of bearing is a journey like any other component. So HAL has acquired, and as a designer, whatever the knowledge I acquired, I want to give a glimpse on that. I don't want to go to the kinematics because you people, basically the manufacturer or people have done research on that, they can give better idea on kinematics. So I want to just know how bearings are selected and how they fit into the gas turbine. That aspects I want to cover. So my presentation covers introduction, then selection, design of bearings, and then special requirements pertaining to the gas turbine engines, aero gas turbine engines, then bearing materials, lubrication, testing, inspection, storage, then defect investigation, failure modes, and standards. So as we all know, rolling element bearings are the key elements of high-speed aero gas turbine engines. Because of that, a lot of innovation is happening. So for the ever-growing demand for reduction in weight, performance, vibration, noise, power loss, and to increase the speed, reliability, and life. So broadly, bearings in aero gas turbines can be classified into mainline bearings, which support the LP and HP rotor bearing systems, and there are gearbox bearings, then accessories bearings. My presentation covers most of the time on mainline bearings. For the mainline bearings, the selection and or design of bearings or right bearings is very important from the point of selecting a proper bearing arrangement for the smooth operation of the aero gas turbine engine. And also, we all know that in aero gas turbine engines, bearings have to operate in a very harsh environment of very high temperature, and for the better aerodynamic performance, they have to operate at a very high speed. And dimensions of the aero gas turbine mainline bearings are decided by rotor dynamics or the envelope limitation of the engine as well as the shaft strength. So therefore, for the selection and design of bearings, these are the factors which influence rotor dynamics of the rotor bearing system, then high speed operation for improved performance of the, and as well as reduced weight, then various loads such as aerodynamics, maneuvering, inertia, unbalance, etc. High temperature from the external environment as well as the internal friction, then the lubrication system as well as the lubricant type used, and the right material to be used to have an optimum and longer utilization in line with the engine TBO. So we take bearing as a whole system of rotor bearing system. So these are the main challenges of selection as well as design of mainline bearing. Like in aero gas turbine engine, the mainline bearings have to undergo combined thrust, radial, and moment loading, supported in flexible mounts, leading to non-uniform variation in deflections, contact stresses, and fatigue endurances. As well as the rolling elements have to undergo high inertia forces as well as gyroscopic moments, as rolling element surfaces are subjected to alternating stresses at a high frequency as well as subjected to high centrifugal forces at high speeds. And also, most of the aero gas turbine engines, they have to undergo high level of maneuvering, so that additional load also comes from the bearing. And also they have to operate at high speed at high elevated temperatures. So based on these factors, the selection of and or design of bearings will be categorized into two types, like based on the factors, based on rotordynamics and other design aspects such as loads, alignment, mounting, temperature, etc. We have to decide how many number of bearings are required to support a main line shaft, and what type of bearings you have to select. Then what type of bearing arrangement or fitment is required on the shaft as well as housing. Then what type of bearing housing or support is required, whether it should be a flexible housing or a rigid housing. These are the four commonly used, like there may be some exceptions, but these are the four commonly used bearings in aero gas turbine engines: deep groove ball bearing, angular contact bearing, and 3 or 4 point contact bearing, which have to confirm like precision class ABS 7 or ISO 4, then cylindrical roller bearing. So this is actually a special requirement of aero gas turbine engine, where to suit into the rotordynamic requirement, a flexible cage, that is commonly referred as a squirrel cage or centering spring. Also, sometimes we have to incorporate a squeeze film damper to attenuate the excessive vibrations at critical when it is passing to the critical speed. And sometimes the bearing manufacturers integrate this squirrel cage along with the outer race. I just want to show you some of the arrangements. This is our legacy design PTA 7. This is the first certified engine in India by HAL. It's successfully certified and used for Lakshya aircraft. And it has got a lot of potential. Recently, we have found that it can be used in many unmanned aerial applications. Initially, it was designed for 5 sorties, maximum 5 to 10 hours. Then it was extended for 10 sorties, sea dunking. Then total life was something around 20 to 30 hours. Now we are aiming at 200 to 400 hours life. So it has got it's a simple rotor bearing system. It has got 2 bearings, bearing 1, which is a 3-point ball bearing, and second one is a cylindrical roller bearing. The arrangement I have shown: bearing 1, angular connect 3-point ball bearing, bearing 2 is a cylindrical roller bearing. So both bearings have got squirrel cage, but doesn't have a squeeze film damper because we are using a mist lubrication. So it is not possible to provide this squeeze film damper. So also we have got other class of engine, the type 2, based on GTS. We have developed GTE G60, which has replaced the GPU of AN32 aircraft. It is a simple arrangement. Left is a deep groove ball bearing and right is a cylindrical roller bearing, and it too has got squirrel cage. And third type is it's a Shakti engine, which is powering ALH, like a class of helicopters. It has got one gas generator spool, another one is a power turbine spool. So supported gas generator supported on 2 bearings, and power turbine is supported 3 bearings. Fourth type is it is a 2 spool coupled with the intershaft bearing, where it is driven by both HP as well as LP. So fifth type is it's a big class engine, where intershaft bearing is generally a roller bearing. Yeah. Yeah. Okay. This one, sir. This is the Shakti engine. So similar, we are developing a similar engine called STSC engine indigenously. The development is going on. It's more or less, this is 1000 kilowatt engine, whereas the STSC is 1200 kilowatt engine. Gas generator spool, sir. Next one is this one. RGGs. Okay. Sir. So, and the second type of selection is based on their temperature environment, as well as rolling element surface are subject to alternating stresses with high centrifugal forces resulting into limited fatigue life. So we are using a two for our reference limiting factors DN. Say we are very close to 2 million. So there was a discussion yesterday that maybe but whereas our bearing designers, they were telling that even they can go beyond 2 million also, maybe up to 2.5, and also FN. Based on this, we are selecting the bearing materials and lubrication systems and lubricants. Bearing materials are, these are all the general references, materials are selected based on their high fatigue strength, high hardness, capability, then high wear resistance, shock resistance, heat resistance. For some some requirement, there may be a shock resistance is required, which are subjected to high shock loads. Then heat resistance. Then some applications very good corrosion resistance is required. Then high mechanical strength and high dimensional stability. These are the type of materials. Some used by us like in engine division, as well as some are given by our bearing designers, which we are not using currently. First is a tool steel, which are through hardened, like ASI 52110, that's 100 CR6. That's very extensively used in our technology transfer engines, which are designed from 1950 to 1970, 80s. Almost all engines are using that material. Then later on, they have started using Z100 CD17, that is 440C. So then we have for our corrosion resistance environment, we have used BG42. Then we upgraded to Chromex 40. In a case study, I am going to explain that how you change it. Then now after 1980s, M50 is most commonly used in aero engine industry. Also M50 nil also. Then ceramic material is now started since last 15 to 20 years. A lot of application has come. So same explanation I have given. Chromex bearing. Chromex bearing, actually it was developed by SNFA, and we also used in our application legacy design. Then there are some new materials like Grenadier, also referred as Nitromax, VC440T, 444. They are all used. They are being used presently, and they are replacing 52100, M50, 440C, BG42, and Chromex 40 materials. And in some applications, they told that some of the rings can be made using Inconel 718 materials. And ceramic nowadays is commonly used for high-speed ball bearings for their higher wear resistance. And we have used way back in 2000 itself, we replaced BG42 balls into ceramic, and they are working fine. Ceramic ball has got advantage, material has got, it is 42% inertia force exerted by ceramic force ball is 42% lesser than steel ball, but it can be a disadvantage because of the modulus difference. They can induce very high contact stresses, so it has to be designed properly so that the contact stresses are within the limit. And bearing materials for cages. These are some of the bearing cage materials used in our engine division technology transfer programs, as well as for our development we use. So hence based on this, like a selection of bearing material at times can be iterative depending on the internal external operating conditions of the aero engine. So as I told, we take bearing as a system. So that a lubrication system is very important for the longevity of like proper functioning, smooth functioning of rotor bearing system. So there are like these are the types of lubrication we use it actually, grease lubrication for some of the accessories and air oil mist. PTA 7 uses oil air mist lubrication. Then some requirement there is a oil bath lubrication also. Then closed loop circulation system using a pump driven by the engine itself as well as driven independently. So this is the like oil system. So total system like it itself is a complex. We have got a system oil system engineers who work on improving the oil system for proper lubrication. The circuits. So based on all these things, design of bearing in a gas turbine aero engine for specified requirements such as load carrying capacity, speed, temperature gradients, misalignment, minimum drive required, preferred material and lubricant system can be like this estimation of displacement and contact. This is all shared by our bearing design manufacturer. What steps some of the things they share with us. Based on that I've listed estimation of displacement, contact stresses, then bearing geometry definition involving stress and life calculations, then diameter clearance variation, calculation of interface contact stresses, hoop stresses, minimum fit or fits to be used, then a free state bearing geometry comprising of free and operating internal clearances, cage selection, cage section with clearances, pocket clearances, etc. While like from our point of view, we want to look into critically these following things like minimum, and that's what we always give stress on these things, minimum and maximum loads on the bearings which have to be considered, then bearing mounting with preloading and stiffness and clearance details, lubrication with viscosity, degree of contamination, shielding, etc. Then steady state and occasional transient overspeed, because most of the time our engines will be like overspeeding above 100% speed. That has to also be to be considered. Then operating flight cycles. So this is like the calculation of life, like as ISO 281 and IS 23821 life, like L10 life is given like this. So whereas now we use like some of the factors try to have a better life factors. Then coming to testing, after we design, manufacturing, everything, that bearing has to perform to its what for it is designed. So testing is very important. Like there are testing methods for performance and endurance testing on test ring, then performance and endurance testing on engine, and in service testing. We collect a lot of data, and based on data we estimate the performance of the bearing. Performance testing of bearing is carried out for the following requirements. Like we collect a lot of data such as bearing temperature variations, frictional torque characterization, estimation measurement of oil consumption, and variations in bearing dimensions. Then in endurance testing, we try to collect bearing temperature variations, oil consumption, then vibration patterns, variation in bearing dimensions. At the end, whatever the bearing is designed, it has to perform inside the engine. It has to undergo the required endurances, and it has to be proven in the inside the engine. So the in a prototype engine, we carry out performance evaluation and initial flight required for initial flight clearance of 150 hours as well as engine TBO. And these are the parameters we evaluate bearing temperature variation versus operating speeds, vibration patterns, oil consumption, oil analysis, and oil temperature measurement. Then variations in the bearing dimensions between each interval of testing. So this is the typical, like, we do a lot of measurement, but I have taken only the minimum data we take. Like we take JPT, because bearing temperature, especially RBT, the bearing which is in the hot zone, which will be influenced by the hot gases. So JPT, front bearing temperature, rear bearing temperature, then oil tank temperature, because that is also important. Then vibration. So these are very important, which are always will be monitored, whether it's a production engine or development engine. In the development engine, we do a lot of other measurements. So bearing condition monitoring through vibration measurement. So these are the basics of rotational frequency, ball pass frequency of outer race as well as inner race, then fundamental cage frequencies, then 2 times the ball spin. These are important to evaluate in a defect investigation. So we always know, like, diligently take the vibration measurement and try to evaluate. Then another aspect is inspection and storage. Like we actually, since our collaboration with a lot of foreign country like engines, so they are having a lot of standards. So we try to implement in our design also. So there are the AR standards, there is other standards. So we do maintenance, evaluation, everything. So we have procedures based on our collaboration for each bearing. Intermittent inspection procedures are there. There are task directives, so we check it even after use or shelf life. In between the shelf life, we try to evaluate. We have got a bearing hospital inside engine division, which it caters to many organizations. So we have got a very systematic procedures laid down. Then defect estimation is very important part of our like any other component. Bearing also, if any failure happens or any problem we encounter, we do a thorough investigation. Like we will have a DI committee. So in the we have got a lay down procedure. Like we have to have comprehensive history of bearing, build details, how many, all this information we have to have. Then if required, we will have a comprehensive examination, which will include bearing manufacturing date, shelf life details, bearing as an assembly or individual elements, detailed examination under magnified and microscope, and also lubricating oil detailed examination will be carried out. Then the mating shaft as well as bearing support detailed examination will be carried out. So based on our experience, these are all the types of bearing failures, and we find that fatigue failure is always less than 10%, whereas most of the failure in development as well production engine, the failures more than 90% time the failures are due to overheating, lack of lubrication or oil starvation, mishandling, misalignment, improper mounting, trapped hard particles, corrosion, etc. I will show one case study on this. Actually, we had an issue like initially for this particular bearing arrangement. It's way back in 1980s. That time we designed that engine is a design. So it has got 2 bearings. So and it was supposed to work in a very corrosive environment. So at that time, only 2 material selection options were there. One is 440C, another one is BG42. So based on the advantages of BG42 material was selected. So because in BG42 vanadium with chromium content enhances the corrosion resistance, chromium, molybdenum and vanadium together make up approximately 20% content in the material. Also, it enhances the wear resistance. But unfortunately, both bearings failed before completing the intended service life.
Excuse me, 5 more minutes.
Yeah. So investigation was carried out, and it was found that the corrosion pits distributed all at random over the race face circumference, rib faces, cage, guiding bore diameter, the faces and fillet radius of both outer and inner rigs, as well as presence of numerous corrosion pits and thin scratches all over the rolling elements. These are the pictures. So for that, actually, that time I joined. Actually, it happened from 1998 to 2000. So that time I just joined HAL. So this was the issue. So one of the bearing, it was sent to SNFA, who actually designed and manufacturing the bearing, and they found that corrosion pits are the corrosion is the reason for this failure, and they suggested alternate material. That time they came up with the material called Chromex 40, they gave the justification used. So we used the bearing, and they gave the technical details also. What is the difference of hull stress when used when we replace with the Chromex 40 material, and also they gave the design data. Earlier PG42 we compared with Chromex 40. And we found, we accepted under their justification, we went ahead with Chromex 40, and after using Chromex 40, rings and rolling elements, the bearings cleared 100% intended life, and it's successfully used. So finally, since we are using ISO standard as well as IS standards. We use a lot of American because of the joint features like technology transfer. We are having because most of the foreign manufacturers, they give technical directives to use either their standards or European or American standards, as well as material standards and lubrication standards. So, thank you, sir.
Thank you, Dr. Gonzalez, for your deep insight into the selection of gas turbine bearings. Now, time for questions.
Presently, we are planning to operate the aero engine something around 1500 degrees centigrade. So, but what is the maximum temperature the main shaft bearings come across?
Actually, since we supply lubrication, no? So temperature, actually we measure the temperature, like we don't allow the bearing temperature go beyond 270 degrees centigrade. We measure, actually in every engine we measure the bearing temperature at the outer race. So that is the criteria, so we don't allow.
No, but that is what is my question actually. If the operating temperature is 1500 degrees centigrade, how the bearing temperature will be constrained to 270 or 300?
That cavity design, that's why, like it's a system. So we have got a oil system people, there's a cavity design, labyrinth seal design. So bearing will not be operating under that kind of high temperature, though it is close to that hot temp. So that's why I just give an introduction, because that itself is a big failed. So bearings will not be subject to that kind of a level of temperature.
Yes, sir. One question from my side.
Yes.
You just shown us the modified way of calculating dynamic load rating for a bearing in comparison to ISO 281 that prescribes a general way of equations for calculating the dynamic load ratings.
This is only just like what they share, like
okay.
That's why we are also trying to implement. We generally follow ISO only.
Okay, sir.
But that material factor, loading factor, lubrication factor, and all, no, it will give. We are trying that.
Okay.
That's just I presented.
Right, sir.
Related to the operating situations, are these bearings are being monitored by a conditioning monitoring?
Yeah, so that's what I shown. No?
Yeah.
Every minimum condition monitoring I have represented: bearing temperature, JPT, oil temperature, vibration. Continuous it is monitored. But many development engines we have more like like now telemetry is there.
Yeah.
We are trying to monitor a lot of other parameters.
This sensorization, whatever you are saying, is this been inbuilt done by HL or how?
That's it.
Okay, thank you.
Yeah, we will have more questions in Q&A session. Now it is the time for next presentation. Thank you.
So the next lecture will be on railway bearings. Just let me connect this laptop and then we will do the proceeding. Okay, so for the next lecture on railway bearings, just give me 1 minute. We have with us from Product Technology Division of Timken India, Srinath Upadhyay, General Manager. So he is managing the product technology TERI team located in Bangalore, India, and is providing product engineering and application engineering support to Timken India. He has worked with various tech centers, plants around the world, and he has been with Timken for the last 22 years and held different roles responsibilities, starting from senior application engineer to the current role of general manager. In Timken, he has spent considerable time in application engineering, product engineering and testing. And before joining Timken, he had spent around 12 years in machine design, manufacturing, assembly and testing areas at Kenna Metal and Ace Designers. So first of all, I will request Kulkarni sir to kindly welcome Upadhyay sir with a bouquet and a memento. Thank you, sir. And now I will welcome Upadhyay sir to kindly share his lecture with us. For changing slides, you will have to put this in here.
Oh, okay.
Yes. Just, yeah.
Okay, good afternoon, everyone. First, I would like to thank the BAS and Tata Motors for giving me this great opportunity to be a presenter in this seminar. And also, I would like to welcome each one of you for this 30-minute session. And also, I would like to thank Gururaj because he has given a very nice introduction on the rail bearing. So, it has almost saved another 10-15 minutes for me. So I'm not covering anything which he already covered. So this is my agenda. First, I'll just quickly go through the Timken product range, and then new innovations on the rail bearing what we had in the previous 5 years, and also then I will go through in detail about the EN standards and AR standards, because those are the two standards we regularly use in India. And then I will take you through some of the best testing facility what we have. So we have one of the best facility in the whole world. Maybe I will just take you through and show all the machines what we have. So some of the products here, these are the we have inch product as well as the metric product. Inch you can see here like B, C, D, E, F, G, L, K, M. So all these depending on the axle diameter and the axle load, these bearings are selected. So we have both in inch as well as
in the metric, but here I'm just showing the in inch. Here also there are two designs. One is AP design and another one is AP2 design. AP design is a very old design where you can see the length of the bearing is very high, because here you have there is a seal wear ring. The seals are sitting outside the bearing. But in recent development, like what Gurraj has told, so we have now moved to the new design. So wherein which you can see here, the seals are sitting on the inner ring itself. So we were able to make the whole bearing very compact. And also these bearings are greased, pre-greased, sealed and set bearings. So in the below you can see the components. So you have this is cup, this is nothing but this outer ring. Then you have cone, two cones. So here you can see with the rollers, and then you have one seal here and another seal here, and there is a bore clip here which connects with the backing ring. So so we have full series, it goes up to maybe 40-ton axle load, maybe from 20 ton to 40 ton. So the whole range we have here. On the metric side, we have you can see here from 100 dia up to 160 dia we have. These are most of the bearings are used in the European region, and also in India we are using a lot of these bearing. Currently, if you see UIC 130, that goes, there are two designs, 130, 230 and 130, 240. So those bearings are mostly used here, and we have here different speed also you have, like 160, less than 160, maybe for our normal train applications, where more than 200 we are not using anything here. But I think the nearest will be Vande Bharat train, where we are trying up to 180 km/h. But our yes, all these bearings are metric. So metric is always everything is in millimeter. So we have bearing with more than 200 kilometer also, whatever some of the Talgo which runs in Italy. So those trains are runs much higher speed, up to 300 350 km/h. So we have all the products with the different speeds. And we also have different combination on the seal side. Here you have HDL seal and Eco10 seal. Maybe I will show those things in the coming slides. So we have Gen 1, Generation 1, Generation 2, and this is the latest generation. This is called the Eco10 seal, where there is no contact between, it is like a non-contact type of seal. So this is the latest one. Now if you take the Vande Bharat train, we have used this. So this maybe I will explain the total design on this in the next slide. So here you can see it is a patent design. Sorry. So here you can see all around there is no contact at all. So basically it offers zero torque, and then minimizes of any temperature increase in the bearing. So that will avoid any removal of the bogie from the train, and also it prevents any water coming inside the bearing, and also any grease weepage it stops. So and also it reduces water etching and the corrosion part. So here I have put one this is basically part of our document. We have done the actual field trials, where you can see here, if you have a train with 100 wagons, and if you run for 1 year, the total saving will be around 13,400 gallons of the diesel or equivalent. So there is so much saving by using this seal. So that is the reason nowadays most of our new generation rail bearing comes with this Eco10 particularly in India, no, the first time you used on Vande Bharat train. Another new product is this universal backing ring. So basically, the backing ring is this one. So this you will have a tight fit on the axle, because if there any looseness will basically will wear out the bearing the face. So that will create problem in the bearing. So we have designed a special tube where even after using maybe many years, there is no fretting or there is no dimensional variation. Even though if there is a because of fretting, the dimensional variation, this tube will make sure the constant pressure between the axle and the backing ring. So this is currently we have developed, and it is AR approved, and we are using in I think this is in class F bearing. We are already implemented. So we are planning to put this No, backing ring is basically this is axle. This is axle shaft. Maybe I will go to previous slide where it is. Here this is the axle, right? So this part is the backing ring. So basically that sits on the axle. Axial load is taken through that to the axle. So it is directly in contact with the bearing back face. Inner ring, cone. So this is another development from our side. And also now we are supplying all the housings and control arms for different customers in India and outside India also. So all these are some of the housings what we developed here. Next I will go through the bearing standards. So basically we have two standards, EN 12080, 8182, and second one is AR M934 standard. So these are the two standards we use in the rail industry. So the first one is basically this is railway application, basically for the testing of axle box. So that is 12082. So we test as a whole assembly that includes the bearing, seal, grease, everything. And second one is basically part of Association of American Railways. So basically they are having different sections in that standard. So what we are interested is M934, which talks about the journal bearing and the lubrication part. So first I will go through the EN 12080. So here basically 12080 talks about the whole design, and then the manufacturing, quality control, the frozen supply chain, and then also full traceability. That is very important for all these rail bearings, where you should be able to even go to the the melting shop where the the bearing is started with forging. From that stage up to the final stage, you should have a traceability. That is very important for this 12080. And also you should be able to do non-destructive testing, where we use ultrasonic machines just to see whether any deformation, any deformities are there within the cone, cup, and other components. And we have EN 12081 for grease testing, and then 12082, this is for the homologation of testing of full axle box. This is basically the approval process. Everybody has to go through that. So basically here you can see any changes if you have make once you make the bearing, then you give for the testing. We test, we approve. Later, if there is any change in the design or any manufacturing process or any manufacturing plant, once again you have to go through the same process. So that is the reason we avoid moving these parts or making any changes in the product to avoid these type of things. Next I am talking about the actual approval testing for 12082. So here basically first thing the testing lab should be approved by here in India it is NABL. We should approve our rig for ISO 17025, and then also maybe if it is in Europe, that will be COFRAC. So that organization will come and audit our lab, and then they will approve. Now here basically what we do we apply, we take the application load and then we add 20% for any higher loads, and then also the same speed, and then we increase 10%. So for Vande Bharat we run the test. Basically the requirement was 200 kilometer per hour, but we ran for 220 kilometer per hour on our test rig. And then also here you have to run, these are not short duration tests, these are all like the minimum is 100,000 kilometers, that takes 1 month, 24/7. So otherwise if it is normal approval process, then it may be depending on your the speed, the train speed, they decide whether it is 400,000 kilometers or 800,000 kilometers. So this is basically decided by the standard. Once you tell this is the axle load, this is the speed of the bearing, then automatically you get what you should test on your rig. So the standard gives this is the radial load, this is the axial load, this is the kilometer you have to run, and this is the temperature you have to maintain. So automatically everything is given by this standard. So it was very well established standard. So even most of the people now, even if you take China or Russia, most even US, they follow. We don't do anything much on the passenger side in US. It is more on the freight side, because in US the passenger trains are not running at very high speed. It is very slow speed. So even there there we use this EN 12082 for our testing approvals. So basically here what we do is once complete the test, there are 3 things we check. The temperature. So I think here basically everything is depending on the temperature. So if the temperature is very smooth, then your bearing will have no issues. So that is the reason the output what we check is only the temperature. We see one thing, it should never go above 100 degrees centigrade, and second thing, the difference between inner and outer should not go beyond 20 degree or 15 degree depending on the test. So those are the 2 parameters you have to run continuously for maybe 400,000 or 800,000, and then you have to check. So if everything is fine, then the bearing is approved. So and then also after second thing what we do, the mechanical properties, we open the bearing and we see whether any damages are there, how is the condition of the raceway, rollers, everything. There should not be any damages or any wear mark on the raceways or on the rollers. And third thing is we do a detailed grease analysis, because that is very important. The grease tells you how well the bearing has run. So the properties of the grease tells you whether the bearing is running very smoothly or that is not running very smoothly, because whatever the final testing we do, once we remove the grease, so then the grease analysis tells how well that bearing has run. So these are the 3 things we
visual inspection is there for damage, or some entity like light penetrant or magnetic particle inspection?
No, usually it is not there, but if you have any issues, any surface cracks or anything, then we do detailed thorough analysis. But our experience because we use very clean steel, we never had any issues of any damages on the raceway. Even now currently we are running one test for 2 million kilometer. It will run 1.5 years continuously, so 24/7. So that is for the new generation grease, where 2 million kilometer you need not change the grease. So usually we will not see any issue on the raceways. So our own steel. So we give the we tell our suppliers to give the steel, and then each heat whatever we get, we do a ultrasound testing, and we see what is the size of these what you call foreign particles or inclusions in the steel. We check from that stage. If anything, you have a range, that maybe you can have maybe 15 inclusions per inch area. So we have set our own standard. That is all IP related. Even I don't know. So only thing is decided by our metallurgy team in US. So that makes your steel clean. Because if you have any contamination at that time itself, we stop that heat. Because if you have any issues there, then it will your bearing will not perform, because maybe 70-80% of the your bearing life depends on the cleanliness of the steel. So we give top priority for the cleanliness of the steel. Yeah.
Each organization has based upon the competition, so it also drives on the fast and the performance. That's not like a standardized one. But
Yeah.
Why I asked this question, because the cleanliness of the steel which is used for aerospace, supposedly order of magnitude have this cleanliness of the steel which is used for on-road.
No. See, whatever we use for aerospace steel, that is called VIM-WAR. Vacuum inward melt, vacuum. No. That is, if you do that, your bearing cost will be already people are, No, that we do only for the, aerospace bearing. So that, we don't do here. That is done only in US. So, but the rest of the quality, I'm not very sure, because, okay, maybe. But what we do, every heat, before that is sending to the forging, we cut and then we take a specimen, test every, heat. Correct. Yes. No way. That cost maybe 5 times, maybe. Yeah.
That justifies only for aerospace.
Correct. Because aerospace bearing price also like that, and because reliability is so high, even customer is ready to pay, Okay, next thing is water tightness testing. Basically, here we check how much water will enter inside the bearing. So that is also very important, because these bearings are running outside. So that test, we do. Actually, I will show that in the future slides. And then last thing is field trials. Basically, here field trials, the ISO 12082, they don't tell anything about that, but it is between you and the customer. But usually, we will be in touch with the customer so that we do the follow up and we see the report how our product is running. So these are the three things. And in case of AR, so it is used in North America, like US, Mexico, and Canada. And here you can see, there are different sections. But what we interested is only section H2 that deals with the roller bearing, and also the AA standard very clearly tells what is the fits, or what is the envelope dimension, what is the tolerance. Everything is given very clearly, and also they have given like approval methodology, what you have to do. Everything is clearly explained in this. Somebody asked whether anywhere we get. So you get in these documents clearly each and everything they explain. So it is a excellent document. And then also you have a interchangeability. 100% you have interchange. The AR make sure that even if you are using escape bearing, you can replace with Timken or FAG, because the dimension is 100% same. Even the tolerance should be same. Even the mating member tolerance will be same. So that way the standard maintains. And if you are having a new bearing which has lower load requirement compared to the existing approved bearing, then you need not go through the testing. You can directly get the approval because of this is lower load, definitely your bearing will perform. So that concession actually AR gives. But whereas in case of 12082, usually the customer will tell us just run maybe 100,000 kilometers, because they want to make sure everything is perfect, because that design also we are not very sure whether any changes they have made on their design side. So here you can see there are different manuals. Roller bearing M934, you have each section where seals M959, adapter also known M924. You have grease also, they have already approved grease. So if you are using the same approved grease, then you need not do any testing. And then also you can add new grease by going through the testing. And then you have a standard for spacers,
Excuse me, sir.
seal bearing,
5 more minutes.
and end caps. Okay, so maybe I will quickly run through this. So here you can see this is Ghost. It is basically for the Russian, but most of the things are EN12082. And then even we supply a lot of bearing for China. They also have their own standards. They follow TB 3000, 2000, but most of the things are EN12082. So overall, if you see, China, they only concentrate more on the axle box testing, nothing much. But whereas European standard, you do bearing manufacturing part, grease testing, and the axle box testing. If you take AR, that is covering everything. So you can see even the bearing part numbers are covered, approved grease list are covered, everything is covered in the AR standard. So I will just run through some of the capability what we have Timken. So this is the test rig where we test our bearings. So basically here you can see the control the axle box with the bearing, and you have the fans which will blow at 8 to 10 meter per second speed, and then you will apply axial load in either direction, and then you have a radial load. So and then you measure the temperature at a different location and see what is the difference. So here you can see we actually have 4 rigs. These rigs are really costly rigs. It is more than 10 crore one machine will cost. So we have 4 machines, 2 in Europe and 2 in Bangalore. So we are very fortunate, and Indian actually the railways we use these rigs mostly for Indian and other Asian customers. So nobody else has such great facility in India as well as in the world. These are the 2 rigs what we have in Bangalore. The other 2 rigs is in the Europe. So you can see here this is a new rig. Maybe this is just 1 year old. We paid almost like 12 crores for the machine. So but it is totally with all latest instrumentation, and currently we are running that 2 million kilometer test on this rig. And then we have another rig where there it is shaft is rotating. We have other option of housing rotating. In some application housing also may be rotating. So for testing that we have another rig. So this is the arrangement where you can see the housing is fixed, whereas shaft is stationary. So we have that option also. We have one rig in US, so where you can test up to 13 ton on one side, it is 26 ton you can totally on the axle weight you can test, and then also you can apply 6.5 ton axial load on either direction, and it can run at 2000 rpm. You can test up to 350 mm OD bearing. So maybe I will quickly run through this. So these are some of the acceptance criteria. This I already covered, so I will quickly go to the next one. So this is for the grease. So here you can see the basically this specifies the quality requirement of greases intended for the lubrication of the axle boss rolling bearing according to 12080, the basic standard. So basically here approval we have to run we can run 3 tests. One is mandatory test. some places, no, we have to run mandatory and complete and conditional approval wherever you need only, no, you can do mandatory and conditional. So that detail is given in the standard. And then we have the third one is, no, water tightness test. Basically, no, here no, we simulate the actual, no, track condition, and then we run the product and we, no, pour the water on the bearing. Maybe I will show that in others. So here you can see, basically, no, here it's the bearing. It is, no, we have different tests. We run at no, static condition, or we may run at 25% of the speed, 50% and 100% of the speed, and then we run at a different speeds. That depends on the diameter of the bearing, and then we check 4 hours, and then after that we open the bearing and we see how much, water has entered inside the bearing. So this, we have many rigs, in the US. So that's all from my end, on the testing and the standard side. Thank you.
Thank you, Badya sir, for this very informative presentation from Timken. Now it is a time for questions.
So just wanted to know that the major players actually Timken, SKF and FAG, I think they're the 3 major players here. And
No, I think you have NEI.
NEI also.
Yeah,
So,
FAG, I think not much they are there, but maybe more than 50% is with Timken. SKF is also, equally, there. NEI is now picking up. They have a collaboration with Brenco. So, and then FAG also there.
okay, so my question is more on the from the marketing front of it, is that actually that we are seeing that there is obviously the the investments of the government and the railway infrastructure is increasing, and obviously there is also a transformation which is happening in the type of the rolling stock, right, from ICF to LHP and whatever. Yes, it.
SKF.
Yeah. So what I'm trying to understand is that is all the 4 players who are there in the market, do they have the sufficient capacity to cater to the increasing needs?
Yes,
Or there is still scope for someone, some other players to get into the.
No, I think one thing, getting into is very difficult because of all this, you have to go through 12082, that testing, if you don't have the test rig, you have to do the testing to get into that.
Okay.
That only other option for you is you go to Europe. There are also very few rigs are there that will cost you fortune, and that will take years together to get tested. So it is a long duration, approval process. So
okay.
And RDO is also very strict. They are very clear about their requirement. So it is very difficult to get into that.
Okay.
I want to add what Upadhyay sir has added out. For any bearing, example, if you want to change a small cage or a spacer of plastic, it takes a complete validation cycle, and minimum requirement is maybe around 0.6 million kilometers, and that too for 24/7, and it takes a 6 months time approx, and a field trial. So any implementation in are monitored by RDSO, it takes a span of around 1.5 years with approvals. So that's the reason any change or any product definitions, if you want to introduce, it's always a time-taking process in railway industries, as it's again a safety.
No, very tough. And RDSO is very clear, and anything, even we have recently changed our seal. Just we shifted from one supplier to other supplier. We have to run, and they are asking approval from AAR. So that takes another 2 years, and sometimes they will ask the field trials data. So because it is risky thing, particularly passenger, they are very clear, they don't want to take any risk, they want to see all the approvals. So very, very, very difficult. We struggle so much, to change anything. One small change, is very difficult, because the risk involved is also very high. So, and we don't have any, authority here to approve. we have to go through 12082 or AR.
Another question related to this. You have already mentioned that the rigs cost around 10 to 12 crores.
Yes.
Suppose if an independent lab is required to be set up in India,
Yeah.
the government decides for it.
Yeah.
So can you estimate a cost for setting up such kind of a lab?
Maybe 15 crores. Yeah.
And getting a product
Because one thing, no, you have to maintain the whole room into 20 degree, no, plus or minus 1 degree, and vibration, no, everything, no, it is very difficult.
and for a manufacturer to get the product tested, is there an estimate for test cost of getting it tested?
No, I don't have, because we do everything in house. Maybe escape, maybe.
Take this facilitation. Happy to share the specification. Great. Actually, for this
Automobiles, I think this ARAI is doing. It is an independent agency. Like that, in the lines of that, something can be built up. Because for gearboxes and all, it is having that testing facility.
No, that is right. See, what happens, no, here, the load involved is, no, in tons. Automotive is not so high, no. See, here we are talking about, no, if you go with the class K or, no, GG, it goes to 40 ton, no, the axle weight. So you should have the hydraulic cylinder, which should be able to apply, no, 20 ton on each side. So that is a, no, very difficult. It is, no, ball bearings are there only on the transmission side. It is there, but not on the, because these are all correct. Yeah, see, earlier, no, we had CRB and SRB, but now we are changing, because one thing is, no, taper roller bearing, it is a line contact, whereas, no, in case of, SRB, it may be, not a line, because you have a spherical surface over spherical. So the load carrying may be much better, and also here you can set the bearing depending on the speed, no, you can change the setting. No, but that option is not there in any other bearing. No, if you take a CRB or SRB, you have only the radial internal clearance, no, to adjust. You don't have, but taper roller bearing, the advantage is you, by moving, no, the outer against inner, you can change whatever the clearance or, no, preload you want in the system, you can achieve.
Thank you for your kind attention, and thank you for all the speakers, especially this regarding railway bearings by Gururajji and Timken Bearings Srinathji, and it was a very good insight and informative presentation, especially the historical trends also they covered, how we came from plain bearings up to this taper roller bearings, and the steps for standardization, like and how this design, manufacturing and testing is to be going to, how they are covering through 12081, 82 and 83 and the EN standards. And especially, and very good deep design insight was provided by Dr. Gonzalez into selection of this gas turbine bearings, high temperature, high speed bearings, and their performance testings. And he also delved deep into one of the subjects which I am very interested, that refurbishment. I heard, and I just want to learn from him how this is done, because I have heard for first time refurbishment of bearings. And thank you very much. And we will have the detailed question answer session next.
Thank you for the answer. Can you have a round of applause for Srinathji Patil? So at this juncture, I will request all the speakers from the first and the second session to join us on the stage. Yes, and I will also request Dr. Manish Roy, the chairman, to also join the speakers. Professor Tiwari, Dr. Gonzalez, Dr. Jana. Yes, so this is the discussion session, and So basically, the purpose of this seminar is to consolidate our thoughts regarding formulation of panels in the Bearings Sectional Committee of BIS on subjects of magnetic bearings, railway bearings, and in future on aerospace bearings also. So we have seen very good quality of presentations and excellent lectures by all the speakers. So if there are any more questions left to this discuss, then audience can come forward, and I will also ask the speakers to deliberate among themselves regarding the panels, and I will request Manish Roy sir to lead the discussion on this. So if there are any more questions, please come forward first.
So thank you, everybody, the speakers, also the audience. So we expect a more active participation in this session, and of course we apparently do not have any time constraint at this moment. To me, actually, one question about the railway bearing remain unanswered. That is, what exactly our developments
Coming to magnetic
bearings, I think we have to identify the areas where we expect immediate production or industrializations.
Coming to aerospace grade bearings, I understand there are a lot of
Hybrid bearings in terms of ceramics coming.
But I understand ceramic is used only for rolling elements,
Rollers or the balls. But ceramics are not used in races or even cages. So probably if anybody has 3 questions I have raised, people can respectively try to address. So let us look into the railway bearings. What exactly the recent developments from low speed, average speed train to high speed train.
Yeah, I want to take out this question about the evolution of railway bearings, especially TBU, from lower speeds, maybe around 120 to 150 to 200 kmph. So what evolution has been done on the bearing side? What researches has been done? So that is what I understand the question is. And the development side from the bearing manufacturer, especially if I want to speak about the SKF side. So mainly it has improved about the grade of steels. We have migrated from the quality of steel from which has a higher performances and can sustain for higher temperatures, as well as to have cost effective measures, because the expectation is also on higher performance with the lower pricings. So that we have done on the steel grades. We have worked on different steel grades, as again the recipe is about and it's in the not in the parameter of standardization, which needs to be maybe in the course of time. And the second one is about the through hardening as well as the case hardening. So these are the 2 parameters where we play bearing manufacturers for the rollers, which gives an optimum performance increase. And lastly, about the grease. The greases are been given a much importance nowadays, which can have good capabilities, and they can sustain at a higher temperature as well as higher load conditions and a higher life. So with that 3 parameters, so now we are migrating from 150, 130 to around 200 kilometers per hour. But of course, the expectation of high speed trains, which is like the corridor which is running within benchmark with other countries. So again, this type of bearings, the high speed bearings, needs to be worked from product portfolios of bearing organizations. This is my view. Maybe other sir can add.
Now, in addition to whatever Gurraj has told, so what we did, one thing is we changed the cage, from steel to polymer cages. So that also, helped. And in addition to that, you have seen, I showed the Ecoton seal, because as the speed increases, your friction, will be, much higher. So we have to reduce the heat generation inside the bearing. So what we did, we had this Ecoton, zero torque seal, in which, you can go much higher speed, even though, because speed will not matter when there is a non-contact. So any speed you can go, even 350 or 400 kilometer. Usually, seal is element which is contact type. So that, we worked and we developed this Ecoton seal. I think you have seen also, the 100 cart, if you pulling 1 year, the saving, that is a huge saving. And also, second thing is, the temperature side. So, there is no limit from the seal perspective. So, and then third thing, as he has told, on the grease side, so we tried with the different grease, maybe SHC 100, SHC 220, and by putting different quantity of the grease inside the bearing, we measured the temperature. So where we get the optimum temperature, what should be the optimum quantity of grease, that is very important. Now we have seen huge improvement when you reduce the grease, maybe 10-15 grams, because that makes a lot of difference. So we have done a lot of R&D on that front. So now we are able to, even we are able to run 300 plus kilometers on our bearings.
One point I want to just add in addition to what Mr. Rai has told about the refurbishment. There was one question about the refurbishment where he was telling he has not heard of. Railway bearings are the one who are in need of refurbishment. We provide around 2 additional cycles of refurbishment where the life cycle can be extended up to around 0.6 million kilometers approx. Yeah. Yeah.
Double the life.
Double the life.
No, what we do, once they have the bearing, we get the bearing back, and then we disassemble. Anyhow, cage is useless. We will throw. We have to press a new cage. Then we inspect, both inner rays and the rollers and the cup, and we see whether any, wear marks or anything. Most of the places, because of the very clean steel, we don't see any issue. Marks. Then we do a grinding, and then we set, the bearing. No, balls, nobody will do, because ball bearings, first thing we don't use much. No, roller, we replace, because roller, not a big cost. Maybe few rollers you have issues, so throw those rollers, use a new roller. No, new grease, new seal. So it is a brand new bearing. So Indian Railways does, everything every time, after maybe 3 years, 1 million kilometers, they send, that is a big business actually. Yes, but you talked about aerospace refurbishment. I don't want to get into aerospace refurbishment, because the reliability required is 100%. So we never know anything on that. No, anywhere you should not do. See, because even if you see landing wheel, they use our bearing in the, almost 95% of the aircraft as a Timken bearing. What they do, they, after that they throw that bearing, they don't use that. Because you never know, because if something goes wrong, all the people on the flight, will be, Yes. Even a small abrasive, if it comes out, damages the whole bearing. It has happened once for us. In shop testing we were doing, night riding, peeled out, damaged the total bearing. Some abrasive particle came out, and it totally damaged it.
Aerospace is altogether a different ball game. But anyway, I had yet another question. Like, is there any special coatings or surface engineering is now appeared for bearings? And I think this is more relevant if we are thinking of hybrid bearings, where we use rolling elements and metallic bases. So, Mr. Vangelis would like to highlight that hybrid.
Actually, we introduced hybrid bearing way back in 2000 when we replaced metallic rolling element, that is ball, into as ceramic, and it has performed well. And I heard there are other engine, aero engine global, they're using ceramic all, even races also, but I don't have full information on that. But after using ceramic, it is performing very well.
Just I would like one person is sitting there. Yes, with Solai Raju. I think you have also not thinking of working on hybrid bearings. Can you highlight something on who are the manufacturer of the ceramic balls and what are the ceramic balls we are using, and what is the status of hybrid bearings usage in India now? You'll give you a mic. You can sit in your chair and tell. No big issue.
As on date, actually, industrial bearings like ceramic ball bearings are being used. I mean, balls, but in aerospace application, people are not to that level because the research are on like you. But the advantage in aerospace application because speed, the DN number in which it operates, it's more. So that has got a unique advantage, and the temperature of operation also is there. So for that, ceramic balls have a better characteristics in its operation. Now, otherwise, in industrial application, normally the ceramic ball or hybrid bearings are being used for the motor electrical applications. So, but when in aerospace, to the aerospace sector, these grade of balls need to have a higher bearing accuracy. Like we talked bearing ball grade as 10, 5 and 16 and so on. So for aerospace application, as the precision class is requirement is higher, the balls also should have a higher precision class to the order of grade 10 at least. So to that class accuracy of balls, I think to my knowledge, nobody manufacture in India, in the country, and we are trying to establish some of the process through CGCRI, CSR. Some work we have started. We are planning to have a silicon nitride in the balls.
Ceramic is manufactured. They are manufactured balls. You have to do this.
Oh, we have many.
I think there is some escape. You have somebody, some hybrid bearings in operation at this moment.
Yeah, please, let us know.
Yeah, Harsh, can you give me a mic? Not working?
So from a Schaeffler point of view, definitely there are some of the applications where we have already initiated the hybrid bearings. If I give you the example with respect to the electric motor application specifically, the present trend, what all the manufacturers what we are using it are the insulation of the outer ring is there, because we have to, the requirement is that the bearing, the current should not pass from the outer ring to the roller and to the inner ring. Otherwise, there will be a fitting marks will be there, and then the bearing will be destroyed accordingly. So now the upcoming trends, what we already have it, that in order to have the specific insulation on the bearing itself, we go for the ceramic rollers applications, so that we change the rolling element from steel to the ceramic, so that we can discontinue the flow of the current from the bearing itself. So this is one of the application already in the. The races remain the metallic only. Only the rolling element will be changed. No, it is not so. It is not so that it is higher. So some of the applications we already initiated. Some of the more analysis we are already going through it for which different applications. But the concern with respect to the wear of the races will be more. It is not so. We are already giving the load carrying capacity and the limiting speed as per the required specification. It's almost equivalent to what we are using with the steel only. So it's not, we are not deteriorating the, either the load carrying capacity nor the limiting speed of the bearing also.
See, what we are doing, particularly on the ceramic balls, when you are using, your speed will be much higher. The load will be much lower. So, once the speed is higher, load is lower, then we don't see much wear on the inner rings. So, I have not seen any bearing with the ceramic inner or outer. So, but all the machine tool, wherever you have high speed, grinding and all, people go with ceramic ball bearing. So we have full range of ceramic ball bearing. And also now in railways, lot of traction motor bearing that comes with ceramic because of the insulation part. Because if you use a ceramic, that will not conduct, non-conductive. So that serves that purpose.
For Vande Bharat, regarding the whatever you told regarding the modifications for the high speed railway, in terms of DN, how it is closer to the aerospace bearing in terms of DN?
DN is not like aerospace bearing.
Okay, it's not.
Because if you take, for example, 200 kilometer per hour speed, 200, I think the wheel diameter is around 36 inches. So take 1 meter. So for one revolution, 3 meter it runs. So for 1 minute,
But
1 minute.
they're
will
not
be-
comparable.
No, it is not comparable. So speed maybe like you have seen our test rig can run maximum 3000 RPM, whereas your engine may run at 20,000, 30,000. It is not at all comparable.
What about the, you told about the seal modification, you told about the coating. What about the fitness and the tolerance? Whether you improved on that for high speed bearing? Or
No, because those are all is governed by these standards.
for high speed, is there any different standard?
No, same thing.
Same,
Yes.
same. Yeah.
From the Tata Bearings or Tata Steel, I think you are from Tata Steel. Yeah, you have some recent understanding about recent developments of bearings, or are you trying to introduce any kind of coatings,
Give me the
coating
mic.
for the bearings parts? Yeah, Mike, please.
Just to sum, there have been a lot of discussions on this ceramic bearing. Just like to add, we use a lot of ceramic bearings in the high spindles, which we are using for the raceway grinding. And the life is very good. And as such, there is not much of a, when you use ceramic bearings, should not be too much of shock loads. Otherwise, there will be a problem. And if you see the lubrication part, I think simple oil mist will also be able to do instead of too much of a lubricating or some grease or other applications like that. So that is one part. As far as development on the ceramic, why ceramic balls are being used for that, avoiding the fatigue failures because of the conduction of the current from the inner to the outer. So there are also some requirements also and some developments by the EV segment where insulating grease are being also used. So the ball will, inner and outer ball will be metallic, same normal bearing steel, and they will be using non-conducting grease. These are available. So this is one. Yeah, we had some apprehension that the EV segment will ask for because the product drawing, whatever we used to receive from any of our customer who are in the EV segment, that the RPM will be some 18,000, 25,000 like that. But however, when we calculate on what is the speed which is coming on, it will be taking off. The speed will be so high. So when we actually in practicality we went to in discussion with them, then the speed is limited about 7,000 or 8,000 it will go. So it was very astronomically some ambitious, some sort of absurd requirements which were coming in. But yes, but in some requirements these type of things are required. Probably some things we need to do. Regarding the coating aspect, yes, we tried out some coating and but results were very encouraging. But for mass production and other aspects, there were a lot of constraints in the, in Proto we had developed with our R&D center in Jamshedpur along with our Tata Steel entire.
this thing. That was quite successful. But the main problem what we were getting is, like the surface roughness. Okay, while before you coat the thing, you have to be very, very clean, and this, otherwise that is because the coat level of, the depth of the thing is also detrimental for, we are doing it in the ball bearing, so radial clearance is important. So, and we cannot again rework it. Once you coat it, you cannot rework it. Those aspects were also there. So there are some challenges for, bulk production on that aspects. So, but however, whatever we made as a proto this thing, and we also validated on our test rigs, we were getting almost, against the normal bearing, we were getting about twice or 2.4 times of the life. So those things are there, but not very, conducive for a mass production.
Keep it
Yeah.
pending for some time.
Yeah.
Unless the application makes it.
Right.
more
So I have two questions here. Like one thing, what you had. No,
Only
it was
races.
only on the raceways. Only on the raceways. Ball we were using the normal one, just without any.
Balls can be thrown, no? Balls are rollers. They are such small parts that can be, if something goes wrong, you throw it. They are consumables.
We have worked on the coating. This is not this is like we have different coating like thin dense chrome, that is on the bearing. Then aquaspex coating, where you have a lot of water, so that prevent from rusting. And then also we have like engineered surface, where we put very maybe in nanometer on the surface, and then that will be very hard, maybe 65, 68 HRC. That is on the raceways as well as on the roller. So wherever particularly the wind energy, a lot of bigger bearings, we were seeing a lot of damages. So those places we use this coating, and because that is very slow speed rotate, so that fretting issue was there. So because of this hard surface, we are able to eliminate that problem.
Yeah, no, they see, when it comes to coatings, there are coatings can be classified under different heads. There are certain coatings which are very hard and very wear resistance, but they doesn't really reduce the friction coefficient. There are certain coatings which are not very hard, but they reduce the friction. They are self-lubricating kind of coatings.
Correct.
There are certain coatings which might not be self-lubricating, may not be even wear resistant, but they are very much corrosion resistant.
So you are absolutely right. That is the reason I told this wind energy application is slow speed, but you need a very hard surface because of the fretting. So we are able to resolve that issue because it is not very high speed.
See, the coating thickness is also very important,
Yes,
because once we do the finishing of the races, we do the super finishing, then we do the coating.
Yes.
Now, once you do that, you need that relationship for maintaining that radial clearance. Otherwise, what will happen for the ID and the OD part? In OD, you will be depositing, and ID you will be increasing the quotation. So maybe the you have to generate scrap, basically oversized inners, and then you coat and make it within the tolerance of -0, -6 or whatever.
In this figure also
challenges.
there is another important thing. Coating when you deposit,
Yeah.
majority of the techniques, especially PVD and CVD techniques, thicker the coating becomes, less adherent the coating is. It generates a lot of stresses within the coating itself.
So it should be nanometers. Yeah, that is the reason.
Optimum thickness. And if you do very thin coating, that may not serve the purpose at all, eventually. If the coating, if you have the same lifetime, there is no point wasting extra money for putting the coating. So I think there is also another critical
See,
aspect.
graphene is a very good technology which is already well established in Tata Steel. So we also thought of making certain things, but then our roughness and other things were way beyond this thing. We can't, because here we are
Graphene and all must be nanometer level.
0.0402. We are not able to maintain. So,
Actually, this coating technology you have to use to solve the problem, not like your standard product. So you have a problem which you are not able to do anything. This is the final solution. So coating, that's what I told wind energy. No other way, we could have had a harder surface. So that is the reason we went there. But it is very costly, and you can't use for your general application.
There is one coating which is now for quite some time in the scientific field. They call it nanocrystalline diamond films. Now, one of the very important thing about the nanocrystalline material, that is making material nanocrystalline is the only way not only to enhance the strength but also enhance the ductility.
But in diamond coating, what is found, even though coating ductility may not be very important to measure, but nanocrystalline diamond doesn't have higher strength than that of the diamond coating. But diamond coating is not able to play a role in such kind of application. Main reason is that its roughness is very high. You cannot have very smooth diamond coatings. Secondly, if you put a diamond coating on any of the part, if you put diamond coating on races, your balls and rollers you have to replace much more frequently than using it. Nanocrystalline diamond coating is one thing which is very tolerant. It is corrosion resistant. It reduces the friction coefficient because all diamond coating has self-lubricating factor. It is also wear resistant. It just optimizes everything. But there are two problems with nanocrystalline diamond. First of all, you cannot deposit it at lower temperature. As you said, after finishing, you cannot expose it to 500 degrees centigrade. That's another problem of using it. Second thing, the nanocrystalline diamond coating has not come in the commercial level where you can really coat a large area. So there are constraints with everything.
See,
anyway,
if you are talking about the surface finish, for that coating may not required. So the cheapest and the best process is isotropic finish. So put some chemical and you just tumble that gives you 0.1 micron. So that solves your all the lubrication related issue.
Okay,
So
I will now move out because one of our speakers has to leave
I
shortly.
would like to understand various application for this magnetic bearing.
Yes.
In the current.
So we are now graduating to magnetic bearing business.
Quickly, I'll respond to that question.
Yes.
Yes, okay. Missed the slide. So, application actually, based on our experience, as of we understand, very specific area. So far, people are trying to use magnetic bearing. Say nuclear power, what we are working with them. So that is one area. And the high-speed rotating system, particularly in aerospace application, or in automobile also, turbocharger. They are rotating at very high speed. Those areas, hybrid magnetic bearing, passive magnetic bearing, even some oil bearing, aerofoil bearing, combination can be used. There are even process industries or I think in oil industries, there are slurry pumps and those areas also people are trying to implement a magnetic bearing.
Is there any limitation on the RPM? It cannot operate at 5,000 or 7,000 RPM?
No. In low RPM also it can. Even
why it
wind
won't
energy
be applicable in automotive segment?
Initial cost actually. Cost will be the main factor which will stop it. I mean, automobile you may be talking of 100, 200 rupees or 500 rupees bearing, but which is not possible to develop magnetic.
But are
bearing
these hub motors which are being put in the rear wheel of EVs, are these not?
I have not come across to that.
Those are all with bearing.
Yeah,
No, those are not
conventional.
with bearings. Those are not.
No, I understand there's a lot of potential of magnetic bearing in many respects.
Yes.
But what is the one government of India should target that we should immediately put magnetic bearing in this?
Energy sector, wind, energy storage flywheels, their potential area people can work on that. Yeah, that way.
So maybe BIS also can think which way we can pursue government.
Because we are working more towards energy storage system.
actually I got one request for that flywheel. So that weighs 22 ton, the flywheel, diameter is 6 meter. So he asked me to select a bearing for that. I told no, I don't have solution. So magnetic bearing is the best solution for that.
Yeah, that can be looked into that.
Yes.
We identify one area.
Yes.
Professor Tiwari also
would like to respond to him.
Can I request I can leave this moment?
Just
Sorry.
before you leave, I just want to make a small announcement kind of thing. That is, BIS is planning to have some research also in these areas. There are many areas I have found. I am not sure. It is only my perception. Please do not accept that or think that this is the area we should go. It is only my perception. I am thinking we should make a document, very well document, in terms of application of magnetic bearings in strategic applications. Magnetic bearings for strategic application, and the people who are working in magnetic bearing, we may take about a 1 year of time, or maybe if necessary we can extend it beyond that level. And BIS can give a small funding in terms of, suppose we have to meet somewhere else, BIS can probably sponsor for at least for the government servants the traveling cost. The funding from BIS is only in connection with the travelings.
other contingencies, traveling and little bit contingencies, which should be very limited. BS can think about it, and also that this sounds to be a proper. Okay.
Apologize for my absence. I was enjoying the talk. Thank you so much.
Thank you, sir.
Regarding the, I think, motor which you are talking about for E, so there are now bearingless motors. So they combine the magnetic bearing and the motor together, so that there is no physical contact between the wheel and the, I think the bearingless motors are also, I think, bearingless. No, circular.
Linear motor is
Not linear, circular. It can rotate. Yeah, bearingless motors are available. And other application is it told regarding the flywheel storage system. So there are two things in that. One is for charging, charging stations for the, so because you can store the energy in the kinetic energy form, and then whenever some vehicle battery has to be charged, you can use this kinetic energy, convert it to the electrical energy and that. But now even in the vehicle also, people are trying to put this kind of kinetic energy, and it can be converted to electrical energy, and the motor can take that energy. So there the application, you require high speed, because the rotor you would like to have small there, but speed high, so that you can store the kinetic energy there. Yeah, so that is we wanted to supplement.
Sir, one question for the aerospace bearings. Which kind of bearings can be taken up as the first stepping stone in standardization? Maybe Gonzalez sir would like to answer this, because we are talking about airframe bearings, but what could be more economically viable and useful for to standardize in the aerospace bearings?
Deep groove ball bearings are very extensively used compared to other bearings. So maybe that is I would like to ask Raju.
Because that finds a lot of application.
Yeah.
That can be taken up as a first front case development, because then comes cylindrical roller bearings are being used. Then in the engine application, we have a split 3-point contact bearings are there. So widely deep groove ball bearing DGBB can be taken up. Only in the when it comes to aerospace application, the precision class is the main thing. So with that consideration, we can start at DGBB. Okay, sir.
Yeah, I think I also agree. I think ball bearing, cylindrical bearing, and the split inner ring. These are the three, I think, extensively.
Yes, sir. Yes, sir. Sir, and one more question.
I think we are planning to have a meeting.
Yes, sir. Yes, sir.
After we have this meeting, probably we can give a better answer to BIS about this. And my understanding is we should only, for the time being, for aerospace grade bearing, we should only concentrate on all the bearings which are made of M50. M50
Yes,
still. After that, probably we can graduate to M50 nil. Then we'll think of rest. For the timing, little is enough. I think M50 itself is quite extensively used. What are the varieties? But before that, I think we need to have that meeting
Okay,
to
sir.
know
Fine,
and
sir.
understand which part of the engine we are using, what kind of bearings, and what is the material we are using. It has to be substantiated by why we are using this material and this kind of bearing for this kind of
Yes, it is.
locations. Understand my major objective of that meeting, that will be, I would prefer to have it in Bangalore. Maybe I will insist on GTI or AD to organize it,
Fine, sir.
but we'll have it as early as possible. Okay.
Yes.
And but then there is one more thing, if anybody can address this. I think one of the important issues of aerospace grade bearing is to keep the bearings at a lower temperature. So temperature control in the system, how it is done, and what are the new methods or systems are coming. Anybody can answer it. I'm not insisting on.
Sir, I'll say a few points on this. Actually, all these aerospace bearings are mostly like a vacuum packed and with preservatives. So basically, these bearings are mostly of steel, and the cage will be of bronze or again steel category. So it can be stored in a normal room temperature itself. There will not be any specific requirement. Okay, sir. Okay.
Aerospace engine operates at 1500 degrees.
Fine, fine, sir.
But bearings are not.
That actually, that as sir told, yeah.
Yeah, that is that's why in an engine, aero engine, lubrication system is very important. That's why we have like a design of pocket, like a CFD analysis will be done. How that there's a cooling system is there, and oil system also. The lubricating oil, there is a oil cooling system is there, so that will be cooled. So it's always that the system will be in place. Like a temperature will not be go beyond the.
So the lubrication is
Yeah.
a lubricant or it is a coolant?
Both.
The kind of lubricant which
Yeah,
is the efficiency
it
of
does that elasto aerodynamic that film, as well as it is a coolant. So that works like that. So that is that parallel. That's why in engine development, all the systems run parallelly. So when we select a bearing, that lubrication system also they will work. Lot of design activities will be done. So only when everything converges, then only is.
separate out with civil aircraft and a fighter. Civil aircraft, fortunately, doesn't operate at 1500 degrees. I think the operational temperature of the engine is some 1000 degree or 800 to 1000 degree. Maybe the cooling system which is available today. Yeah. So if the engine is operating at 1000 degrees centigrade, it can keep it less than 300 degrees. But the fighter is supposed to operate beyond even 1500 degrees. There are a lot of designs that are coming to operate. So if you are operating it at 1500 degree, engine is operating at 1500 degrees. Whether we have efficient cooling system, it will keep the temperature to 300 degrees centigrade. And that's why M50, M50 and M50, which can operate at 500 degrees centigrade. And but the advantage of the fighter, it don't operate for sound. Both drop the bomb. So that's probably one of the optimization. But I think this is another area where we need to have enhance our knowledge and understanding of how and engines.
Regarding the, I think I will add to this. Even I think some of the requirements are very short life of the bearing is required. So there even the fuel is used as a lubricant and the cooling both. Yeah.
Well cooled.
Yeah.
Yes, actually very high quality fuels are used in aircraft. But see, as far as temperature is concerned, like whenever we do some failure analysis of bearings, warranty issue or some failure thing has come, okay. So there is a standard by the metallurgical this thing whereby color of these races can also speak about till how much temperature and how long it was there. So generally about 2 hours at that 400 degrees centigrade it has to sustain, then that color changes. So whether it is reddish, bluish and that, so that template we see and check out. So we can tell definitely the customer if he's done okay, it was actually some lubrication failure. Otherwise this type of temperature rise should not have happened. So that is also a thing which is already there in the failure.
No, I think here you should be very careful. Sometimes because of the lubricant, you will have stain like thing on the surface. So best way is to the microstructure of the metal by cutting, by seeing the the transformation of the cell. So we do that, but just by seeing the surface we never, because there are so many reasons maybe. So best way is take a section and see the change in the structure. So because if there is any the martensite or right, those changes will happen.
When people do failure analysis, they do all sectioning. They must be doing. But he is trying to tell some shorter way, quick way to tell what exactly can be done, what is the possible reason.
That is without any destruction. Without any destruction. What you said yes, is also done. But today, even the customers, earlier we used to have those things, but nowadays even our customers are getting very bearing knowledge and failure analysis and all these things. And everybody is having the softwares also to simulate those things. And then they are only telling the DVPRs, the aisa karo, aisa karo.
what we talk about RDSO testing and validation, it is there in auto segment also. Everything has to be done.
Is there anybody who wants to contribute something else in this?
I think Bhatia sir was trying to ask some questions. Do you want to contribute anything to this?
Nothing.
Actually, I was just trying to touch upon the presentation was given by by the Timken and the SCF team regarding your question was with respect to the high speed bearings. Your question was with respect to the high speed, how we are going to take care in the future with respect to high speed trains requirement. That was, I would like to touch upon that the EN standard what we are talking about, no? That definitely take cares about the speed limit below 250 and above 250 also. It's have the inside of that also. Second topic, your minister, you had touched upon the coating of the part. The coating point was that from the Upadhyay sir already discussed regarding the from the wind application point of view, and even from the railway point of view. I just like to just touch upon that part that we have they have not tried to cover in the presentation only. I like to touch upon that the bearings what we are using for the railway application, either it will be a open type bearings or it will be a closed type bearings. The housings are of different types. So depending upon the application of the housings, if you the coating has been defined accordingly. If you freight car, normally we have the open type of the bearings. You can see even the bearing from the outside also in the and that time we have the specific coating with respect to the corrosion resistance. Coatings are already available and we are already implemented. I think all the manufacturers are already doing from the coating point of view.
It is phosphate coated.
Yeah,
All
that's
the
what-
bearings are phosphate.
So
coated.
that's what so your question was with respect to the coating and this high speed requirement. So I thought I should give some insight for that also. With respect to your topic with respect to the high temperature, how we can take care with respect to the, I understand specifically he is focusing with respect to the more ball bearing type. I was just asked the question to you that normally we as a bearing manufacturer talk about the dimensional stability, the operating temperature. Okay, normally we talk about we even define this in our catalog also, that at which operating temperature and what is the stabilization temperature, we give the confirmation to the supplier, to the customer also, at which temperature our dimensional stability will not go away. So normally presently at what temperature you is being followed at your end? Are you aware about that? Which type of the temperature stabilization you expect from the manufacturer with respect to the, if we give the example S0, S1, 300. So this is the expectations what you have it from the.
We keep 300 degrees centigrade is the maximum temperature of the bearing.
Where the 15-degree temperatures are what you are asking the cool. You have to just think about the cooling system only, not more than. Normally, even our catalogs, everyone speaks about the catalog.
I think in the presentation what I shown is the APT was something around 7. It means that surrounding the bearing, something like 800 degrees centigrade was. But the bearing temperature was like we are measuring it outer is 250. So it must be around 300 degrees maximum.
No, but we have some bearings. No, if you take in X-rays, so X-ray, no, inside there is a bearing. So that bearing goes up to 450 degrees. So we don't use any lubricant. So we use solid lubricant in that places.
Yeah.
Powders, we use. So, but those are all special applications.
It doesn't act as coolant, they are only lubrication.
Yes.
It's the
Yes.
lubrication only.
But bearing itself is stabilized. See what we do when you give higher temperature, the heat treatment process changes so that the bearing will be stabilized, retaining the accuracy, or the dimension at that temperature. So we change the heat treatment process like S1, S2, S3. So depending on your temperature, we change that process.
Sir.
Class of engine. Some people engines,
Yeah,
temperature.
truly speaking, at least we don't have any aircraft which is operating at 1500 degrees centigrade. It's not, but it is like our MCA, SHAMCA is like expected to operate at that temperature. Anyway, anybody from Telco would like to highlight something related to automotive bearings and their recent developments? We're almost finished.
Yes, sir, you can join us on the stage. Yeah.
One person is left, you can join.
Yes.
I mean, that's what we are saying. We don't have any currently new developments that's going on in the bearings section right now. So it's the we have been I mean, no new bearings. We are not using any new bearings from the this part.
Yes, any specific development in the steel sectors for bearings? Integrated steel plant?
Basically, so the endeavor is more on the wire rods, which is actually used for, making the rolling elements. Ideally, what is happening is that the rolling elements, which has been made especially the balls and the rollers I'm talking about, the small balls and the rollers, not the higher ones, where we use 8619 typically, the type of a grade. I'm talking about say 52100 grades actually. Here I have seen that actually that the wire rods are still imported from Ovaco and Diado. We are not making that wire rods from here. So one thing is that the development which has to happen is actually that the wire rods which are for the rolling elements that has to be developed here, because that involves some sort of a higher, probably some additional refining processes, which is not here, number one. As far as Tata Steel is concerned, we had actually acquired Usha Martin, as you know, all of us know. But in that sense also, obviously, the SAE 52100, they're in the process of making, they are already approved with Timken for some of the grades. But at the same time, SAE 52100, we are on the steel part of it. Some developments needs to happen in the upstream processing. It's still, I would say, there are players who are really good, like ISMT, Sunflag, who are there for the races part of it. But for the wire rods part of it, I think there is not a very established supplier in India. That is what, to the best of my knowledge.
Thank you. Actually, now we are working on that front, because now most of our rollers are manufactured in Jamshedpur. So even for the global. So our supply chain team is working on that front.
Okay. Yeah. Would you like to contribute something? Please introduce yourself.
I'm H.N. Shivshankar from L&T, Bangalore. Actually, we have been using rollers, bearings in our compactor applications, wheel loader applications. Okay, I just understood the current developments in the bearings. The discussion here was quite interesting, and some new knowledge with regard to the application of bearings. I have to go back and see where we can really apply this magnetic sort of bearings is what we need to explore. So I will be in touch with some of the dignitaries here, maybe to try and see the new kind of technology in our machineries. Thank you.
I think we had enough extensive discussions. I have identified 4 areas of possible documentation to begin with, which will be useful for all of us and also useful for BIS. The first thing is that I think we should try to identify what are the types of bearings and the material used in nuclear power plants or nuclear applications. We can make a small team, and this would not be a very exhaustive work. Have to start with 1 year time, followed by, as I was telling, that we should do the similar kind of exercise with aerospace grade. For the time being, railway bearings, unless join us, yes, we would like to keep everything in abeyance. And possibly, as Professor Hirani was not there, I said we should also try to look for magnetic bearings for strategic applications only. We should just keep it commercial application aside, because it is going to be an expensive thing. It would be easier to justify for strategic applications, which includes space. We have to have people from aerospace, ISRO, atomic energy, and defense. For the time we take an estimated time of 1 year. Can be extended for 2 years also if situation demands, but if, depending on the progress.
Magnetic bearing conference, what you mentioned, we can write, if you have something in a mind, we can write initially review paper on that. It will give exposure on the BIS to them, and then maybe it will give also the kind of white document to the industry.
Yeah, if we can, if the manuscript can be made something of a technical paper and can be published in some decent journals, that's fine enough. Also, I think one more thing is missing. What are the journals we should try to subscribe? We have not really got enough feedback.
But I understand from my experience, soon all the journals will be online.
Open access.
Yeah, open access. Reason being, now even in IIT they will not get a fund for the journals, right? Which in most of the USA universities it has happened. So,
Even if they accept, they'll put it for 9 months, 10 months.
yeah, exactly. This is publication will be delayed by 6 months, 9 years, maybe sometime 2 years also, right? So
You have to, days are coming when you have to have paid publication.
yeah, paid publication, but keep a high impact factor and good review and all those things. That way. So in my view, that will be maybe we can do this time.
Open access journal of the future.
Yeah, right. Yes.
Thank you, sir. Okay, so are there any more questions? I think we are over with the discussions now. Right.
Yes, please.
Normally, the rotor system, we want to have a minimum running accuracies, like to have a lesser vibration. So we select rolling element bearings with a lesser radial clearance or the running accuracy, I would say. So for example, these high speed rotors or any rotating system with a rotating at more than 10,000 RPM, we prefer running accuracies close to 10 micron or 20 micron. So whereas in case of magnetic bearings, is it possible to have that kind of control to that levels?
Yeah, with the AMB, people have done already. Permanent magnet is a bit difficult.
Okay.
So that's why in my speech also mentioned that when the real manufacturer come forward, it is possible.
Okay.
Rolling element has come because of the only industry participation. I don't think that academician or R&D lab can achieve this kind of business. So if there is a really maybe standards have been made in the manner.
Okay.
Our sleeves are the kind of the compartmentalized. Only sleeve will be sold by somebody. So those things are possible. In near future, it is possible.
Okay.
If you ask today, no.
Yes.
Right? AMB people have control up to 10 micron. As
Okay,
such, there is no problem.
Okay,
Right?
thank
And
you, sir.
maybe I think Professor Tiwari wants to add anything because I know the 10 micron there's no problem because we have seen orbit with the electromagnet. Accuracy is possible. Now accuracy depends on the sensor accuracy.
Sensor, yes,
If sensor accuracy is bad, then things will be bad. Otherwise, number was some delay time. Whatever sensor response time comes, and then actuator has to really play immediate role in that. So if that delay time and that sensor response both are good, then there's no issue as such. So
Thank you,
you
sir.
want to add anything, sir?
Along with the magnetic bearing, always we have auxiliary bearing, which is having far less clearance, so that it should not strike the magnetic actuator, whether it's brittle. So in no case shaft should hit the actuator. It will hit the auxiliary bearing, which is rolling element bearing, with a larger clearance. It is not touching during the rotation, is free. But yeah, so
That is a clearance.
That will cause a more problem
Yeah.
for rolling element.
Yes, sir.
We don't want any touch should happen.
yeah.
Okay, sir. Okay, yes, sir.
Yeah.
Thank you, sir.
See, even for landing purpose, it will land on that particular bearing. So auxiliary bearing, yeah, and they are rolling element bearing.
In that case, instead of there's a rolling element bearing, I'll go with a permanent magnet. It will not touch at all.
Sir, thank you, everybody, for the interesting discussion session. Please have a big round of applause for our chairman and the speakers of the session. I will request Shri R.R. Singh, Head of Production and General Engineering Department, to felicitate the speakers of the second session with mementos. So first starting with I think Mr. Gururaj from SKF. Sir, please speaker memento. Yeah. Next is Dr. Gonzalez from HL. And Mr. Srinath Upadhyay from Timken. And finally, our chairman finally our chairman, Dr. Manish Roy, for felicitating the for felicitating the discussions. So we have come to an end of this interesting seminar and very beautiful discussions that I believe that it will consolidate into very good Indian standards in future, and it will be a very good stepping stone for development of Indian standards on magnetic bearings, railway bearings and aerospace bearings in future. So, and also bearings for nuclear industry, as we have discussed in the final session. So distinguished guests, respected speakers, esteemed participants, ladies and gentlemen, on behalf of the organizing committee, I stand here to express our heartfelt gratitude and extend a warm vote of thanks to everyone who has contributed to the success of this seminar on different kind of bearings. First and foremost, our deepest appreciation goes to our esteemed speakers who have graciously shared their expertise and knowledge with us. Your insightful presentations and valuable insights have provided us with a deeper understanding of the intricate world of bearings. And your passion and dedication to the field are truly inspiring. And we are grateful for the time, effort you have invested in preparation and delivering the very informative lectures. Thank you to the speakers. We would also like to express our sincere appreciation to all the participants who have attended this seminar. Your active participation, engaging discussions and thought-provoking questions have enriched the learning experience for all of us, and also all the audience who have been watching or will be watching the lectures on the online platform. So the diverse perspectives and experiences all of us have brought to the table have contributed to the success of this event. And our gratitude extends to the organizing team from Tata Motors and Pune branch office of BIS and the supporting staff who have tirelessly worked behind the scenes to ensure the smooth execution of this program. From logistics to technical support and from coordination to communication, your commitment and dedication have been instrumental in making this event successful. Furthermore, we extend our thanks to our hosts and partners in a different capacity for their generous support, and without which this seminar would not have been possible. So thank you so much for hosting this seminar. And lastly, we would like to express our heartfelt thanks to management of BIS and experts of the Bearings Sectional Committee, PGD 13, who have not participated in the capacity of speaker but have been present in this seminar and supported the proceedings of the seminar. So your continuous support and encouragement have been invaluable. So in conclusion, we are truly grateful to each and every one of you who have contributed in any way to this seminar and making this seminar on bearings a memorable and enlightening experience. We hope that the knowledge gained and the connections made during this event will foster future collaborations and advancements in the field of standardization of magnetic, railway, aerospace and nuclear bearings. Thank you once again for your presence and active participation, and we wish you all continued success in your personal and professional endeavors. Thank you. T is available